Hello, hello. Hello, everyone. Hello. Aha. Today is the final day of the Math Clock Contest stream. When making flags in PowerPoint Part 3, I'm not sure. At least a month again. At least a month. Thank you, thank you. Okay. Hello. Aha. Well. So, here are our final few clocks left. It's actually in one page. This doesn't scroll any further down. It goes from 241 to 256. And today, my goal is to end it in 5 hours because I do not have more time. I hope I can end it in 5 hours. So we're going to be looking at late submissions first. I cannot go through all of them and solve all of them because there are like 30 more of them. So I apologize beforehand, but I will just skim through them and we'll take a moment to show gratitude to all the people who submitted, even if it was late. They still finished their clock and wanted to share it with us. So let's look at it. Bam. This is when the contest was over. So some of them we've seen in like previous streams when I thought I had more time. I didn't know there would be so many late submissions. This one, this was like creating a dice that when you roll it in a certain way, you get like 1 to 12 maybe. Yep. I think that was the idea behind this one, which was really cool. And then I think we saw that one. Yeah, this one is on another like cool geometry stuff. Very like simple. Nice. This one is cool too. I think I did this one. Yep, I did this one. And then this one. Okay, this is a re-upload. We're gonna do this one today. I've done these. I've seen this one. Very good clock. This one. This one is also interesting. It's a kind of like a code. And you're supposed to follow down the lines and see which one connects to which, and maybe have that. Yeah. That's very interesting. So, I don't know. X and Y, X or Y, maybe? Yeah. Maybe doing some bit manipulation with things above and then following. Yeah. I guess we start from 2026, represent that in binary, and then start from all the ones and end up in their land stuff. Yeah, that's a really cool one too. By the way, wait. No. Maybe, wait. Let me look at the emails for a second, because I might be missing some of... No, maybe no. Okay. And this one, we looked at it. Yep. Here, this one is find the name of the open problem related to every formula, and if proven true, would yield the correct number for the clock. It's more of a trivia game that needs some internet research in the puzzle. I hope you have fun and learn something from it. That's very interesting too. So it's about all the unsolved problems in math, and although it's like obviously impossible to solve them just for one person to solve them, but it's very interesting in that it lets the viewer like search for it and learn new things about the unsolved problems. So very cool. I think we saw this one. Think we saw this one, but yeah, maybe not. It's yeah, factorial, nice arithmetic clock, and another very puzzly clock with some ASCII hex, yeah, some color to ASCII stuff going on. Meta, yep, definitely try these clocks if you are interested. I think they will be very good puzzles. Zai, would you mind just looking at my 7 o'clock problem? Oh, right. Wait. You mean this one? 5th decimal place? Oh yeah, I've seen the email you sent me. Was it an email or a YouTube post? I mean, I saw the explanation on where you got the number for this lemniscate constant and how it works for like 15th digit, like up to 15 decimal digits or something. Yeah. Huh. This is right. Maybe? Did we see this? I'm not sure. But I guess some... Not that... Yeah. Not that... I guess it wouldn't be that hard. Yep, some nice arithmetic going there. PEMDAS, root 25, gamma 4. Yep, that's 3 factorial. So, nice. Another, like... Amount of letters in word form of Y, where Y is hour on clock. Hour on clock. Word form of Y. So I guess it's about how 4 has 4 letters. And maybe, yeah, no other hour in the clock has that amount of letters. 3 doesn't have 3 letters. 2 doesn't have 2 letters. So cool. Some... what's this? It's Japanese. Ni re... How am I... How do I read this? Ro ni re ni... What? I don't know what this one is. I guess it's about 2026 because ni is 2, re is 0, roku is 6, so ni re ni ro 2026. I don't know how it's 9, but yeah. Okay, nice. Did we do this? I think we did this. Yep, it was cool. This was really cool. We got scratch. Wait, no, this is not the clock, right? Not a clock. Fonts something. Okay, very cryptic again. I don't know if you can solve this one. I don't know if I can solve this one. Maybe you try. Maybe someone in the comments has solved it. No. People replace the S and sign with a Z and separate them. Z-I-G-H. Just Zai? And separate? How is that? Is that 10 o'clock? Is that 10 and 11? How? I'm not sure. Intense difficulty. Of course. And then Mini Cryptic Crossword Volume 3. Amazing. Adrian Chow was making numbers with 2026. Oh, this one reads as N-I-N-E. Oh, that's true. This is kind of an N shape. This has a dot there, so that's an I. N-E. Right. Have fun with this one, Zai community. Yep, everyone, like, try these clocks if you are interested. I believe they have really good puzzles. Ellipsis in Morse code. What does that mean? Alien Funk. That's a song. We have it here. Here, that's Alien Funk. Unfortunately, Dr. Zai's music channel is gonna change the name soon, kinda, maybe. So, it's gonna change to Zai the Fish, maybe. Also looks kinda hard. 3D geometry. Lie on the t-axis and are time-like separated from the origin. And use where Minkowski space-time, right, Minkowski returns 026. How many events in S coincide with the origin? This seems to be a really clever idea. Right. Xylophone. Goodbye. We've got some fun algebra. I don't know how pi to the pi is gonna be 3. I don't know how pi times 4 pi is gonna be 4. I don't know how 9,471 square roots to 8. Maybe it's like about the decimal places or something. Polar coordinates? And then we have bruv. Unfortunately, I cannot see what's going on. That's the question for my 4 o'clock. That's also the question for my 6 o'clock. Okay, I can make out some of them. This is 7 connected to 6. Something 2026. 1, I guess that's also the 1 o'clock from my clock. There's 6022. Maybe it's similar to the 2 o'clock from my clock, and they've done something different with the concept. Okay. Oh. I should have looked at this first. Right. So that one is 1098 by me. Some arithmetic going on here. Right. 6 divided by 2. Oh, yeah, that was a re-upload. Colors. Blue plus red. Red has to be 1. But blue has to be 2. Orange, yellow, maybe. Oh, it's just you make the shapes with these lines. So red becomes 1. Orange, yellow, green is, I guess this orange is this one, so it's 2 like this. Blue is also 1, maybe? Wait. I guess blue where does blue come from? Oh, it's saying that orange, yellow, green is now blue. It's defining blue as 2. Bada-bum. And this is now 3, so this color is now defined as 3, and so on. Right. And this question mark is the sum to all. This is 4, so purple question mark is sum from 1 to 4, so 1 plus 2 plus 3 plus 4. And that gives us 10 and stuff. Really nice. Zai, did you sleep well after that stream? Of course. I had a very good, not night's sleep, very good day's sleep. Cute. US flag. That object artist Asphalt 09 has a very cursed clock about, I don't know, reading. It's like non-composite, non-prime natural number is 1 because 1 is not a prime and also not a composite number. The solution to when a number added with 1 and then doubled results in 6. So if you have a number, add 1 to it and then double it. Before doubling it, it should have been 3, and before adding 1, it should have been 2. So that's 2, and so on. These are very cursed. You have to decipher all these overlapped texts and stuff. There's a Zai logo. Thank you for submitting these clocks. Some hard arithmetic, some hard calculations here. Interesting. By Blood Editor. And then, wait, this is an, okay, this is a repost, I guess. Wait, I went below for some yeah, I scrolled down for some reason. Okay, we were here. Bam. What happened there? Wait, is that a bug? Wait, what's happening here? Why is there a time paradox? Why are there 2 sets of posts showing on my screen? Wait, it actually shows 2 sets of posts. Like, it repeats. It's actually a repetition. Is it's a YouTube bug or something? Blood Editor, Raka, bruv, Typhlosion, and then again Blood Editor. Maybe I've gone insane after all the clocks. Untake. This is my clock. It's made in Desmos. Fully functional, by the way. Yeah, looks like there's a Malaysian flag. G5 plus what? 11C. 11 cents. What is... 20 in base 3 is 6 and stuff. White to move. That's interesting. RE of white to move. Maybe the real part. So the X coordinate, maybe? Not sure. White to move. Moves to where? Move. Very interesting. You should try solving it. You should try solving it if you're watching. One must imagine Zai happy. Endra, did we look at this one? I think we did. Yeah. Yep. 1 to 11. Equilateral triangle. We've seen this one too. This one is a re-upload. This one is also re-upload. Oh, again, that, wait, I am in a... What? I'm in a time paradox again? I'm in a time paradox? What's happening? Am I what okay. Zai is fish. Thank you. 2026, nice arithmetic again. Boom, boom, boom. Thank you. And the Zai clock. Did we look at this? I don't think so. Maybe. Oh, I think we did look at it. Or not. 2 Dr. Zai. Thank you. I think we did look at it. I remember. Yeah, I remember seeing this one. Right. Another. I think I remember looking at this one too. Yep. Another, yeah, arithmetic clock. Everyone, thank you for submitting. Math calendar by the Korean Math Society. Really? There's such a thing? Math calendar by Korean Math Society. So it's like, does it have a puzzle for every day of the year? That's pretty cool. I'm searching on a different tab. Maybe like here, I believe this is the same person. This is from 2021. They've been doing this for a long time, I suppose. This one is like, yeah, 2021 math calendar. 2026 math calendar. Every month, maybe they upload a math calendar. Very, very interesting. So, some geometric distribution, right? I believe, yeah, that should solve to 2. Tetrahedron, just 4 points. 5 is equal to 0, 1, 2, 0, 2, 1. Unique sexy prime quintuplet. So sexy prime is when 2 primes are 6 apart, you call them sexy primes. This is the only sexy prime quintuplet because other than this, you cannot have 5. I don't know, 5 primes that are all 6 apart, because if you do it, one of them is going to be a multiple of 5. If you do this for any other number, one of them is going to be a multiple of 5. 2. And then, of course, it's not. Then the multiple of 5 would not be a prime. Here, it's okay because 5 itself is a prime. And what else? Very many interesting things. So yeah, definitely check out the math calendar by the Korean Math Society. I believe if you like go to their website, this is their website, I think. I don't know where they would post the calendar, but maybe it's somewhere in this website. Notice? No, it's newsletter? No. Maybe it's not here. Maybe it's some kind of other website, some kind of community. But I guess it should be on the internet somewhere. So check it out if you're interested. Some cool math stuff, cool college math stuff. The sigma of 126, and then I guess floor that and add 1 and then gamma and stuff. Okay. Right. I'm not sure what this one is. Maybe it's a magic square. Anyway, thank you for submitting. Find the area of each regular polygon with given side lengths. So there's a formula for the area of a regular polygon given a side length, and let me check it in my notes. It is, where is it? Area is, first you take the square of this and then multiply it by the number of sides, and then divide it by 4, and then divide it by tangent of 180 degrees divided by the number of sides. That's a long formula, but if you write it down, it's not that long. It's long only because I said it I said it in words. It's not that long. It's pretty doable. Maybe, yeah. Yeah, I guess that's why are these like tangent pi over 11, because pi is 180 degrees. So if you square this and multiply it with the number of sides, then you have like 11 times this squared, so 4 times this, right? The square root gets removed, and then you're supposed to divide it by 4, so the 4 now gets removed, and then you divide it by tangent of 180 degrees over 11, so this one gets removed. So the only thing left is the 11 that we have multiplied. Okay, again, square this, multiply by the number of sides, divide by 4, divided by tangent pi over number of sides. And that just reverses this, like, does the reverse effect of this number. This here too, that's why it's 2 root tangent pi over 7. I believe all of these numbers are 2 root tangent pi over the number of sides. All of these numbers below will be that. 20 degrees, that's 180 divided by 9, so that checks out, right? Bam, bam, bam. Axolotl. Did we look at this one? I don't think so. Aleph cardinal stuff. Not sure. I don't know how to calculate that one. I don't know what this delta symbol is, but these seem to be like college set theory stuff. University, college, whatever. University set theory stuff. Right. Very hard clock. Every number is made with 2026, right? So for example, here in set theory, 0 in braces is 1, and if you take the intersection of any two numbers, you just get the lower number. So 2 intersect 1 is just 1, 1 intersect 2 is just 1, and then 1 intersect 6 is also just 1. And then union, if you union two numbers, you just get the higher number. So 2 union 0 is just 2, 2 intersect 2 is just 2, 2 intersect 6 is just 2. And then the 2 is repeated here, so it's 0, 2, 6, and there are 3 elements here and stuff. Right? The hex time, you color pick all these colors and maybe you do A, B, C, you treat them as arithmetic, do these substitutions, right? One has the hidden 2026. Interesting. I believe if you want to solve this, you will have to like open image in new tab and then do this trick to make it the original resolution, maybe, and then it'll do 62C00E, so that's gonna be like 62 times 0 and then factorial. 62 times 00E. It has the 2026. 622 times 0E. Wait. Factorial? Isn't it telling me to do 62 times 0 factorial? 62C00E. 3B03A3. So 3 minus 3 plus 3, that is 3. Not sure how this one works. 2C0002. 2 times... It's just 2 times 2, so that's 4 and stuff. Right? Okay. Nice. Wait. I don't mean for this to be a math clock submission, but here's a fun puzzle. Hydroplane, elegant. Last genus in the above lexicon's dictionary. I guess you're supposed to know about Scrabble. It's a Scrabble puzzle, maybe. I'm not sure what these mean, because I don't know Scrabble. But I guess if you know, then you could try. CSW24? I don't know what that means either, but you could try. Worst thing ever. It's a system of linear equation with 12 equations. Amazing. Definitely solve that with a computer. Drawn in Desmos with 2026. Right. So they drew this in Desmos, and they only used the number 026 for all the equations that you need to draw the Desmos. So amazing. Ceiling floor action going there. O of n? What is that? O of n is just a... Okay, O of n is just a function. Okay. I thought it was the big O notation, and I was confused, but right. And then, after you define all these variables starting with b, you make a list of them and turn them into... What is it? Turn them into... I thought you were turning them into coordinates or like lines. Maybe that's what's going on. That... Right. Very interesting. Oh, I clicked on it. Unfortunately, I now need to scroll all the way back there because YouTube doesn't let me do, doesn't save where I was. Doesn't save this scroll. Okay, I was here. Doctor's eye fish spinning. This one's themed around this number again. Oh, this number again. Oh, this number, this number again. This number again. Interesting puzzle. How would you solve that? Interesting. Odd even. This one is the lemniscate constant you were talking about earlier in chat. Thank you for all the fan art, by the way. I appreciate it. Swiss. This one is the updated. Yeah, that's a re-upload. Wait, maybe I should open this in a new tab or later. This one is also re-upload. Also re-upload. And then some nice arithmetic by PVL Chess. 8 o'clock. And then another math clock. Geometry. Oh, there's only one here, not finished. Looks like M and N is the midpoint of AD, and BC. What is the area of BPC? 5.547. Huh? Right. It doesn't look like it in the picture, but I think A, B, M, N, and DC are 7, 5.5. It should be like 5.5 should be a mean between AB and CD. because these are connecting the midpoints of AD and BC. So this should be 4, because the mean of 7 and 4 is 5.5. So 4? Really? No, that's wrong, because if this is 4, this cannot be 4. So maybe I'm wrong. Okay, but I don't know how to solve it otherwise, so... Right. Here's Grace code. This one, is this the final one? Yep. Another interesting, yeah, wordplay stuff. The last one by Grace Code was really good too, so yeah. Check this out if you want to have a good time solving puzzles, right. And that concludes all the late submissions, I think. We do have some late submissions through email too. And there's a lot, actually. So... Wait, I'll just copy and paste them one by one and just show it. So... wait, I need to go through all my emails. I'm going through all my emails right now. Okay. I'm trying to see which one is the first late submission through email. Ba-ba-ba. Ba-ba-ba. Okay, this one is by... How do I down... Okay, for some reason... Alright, this one is by... ADHRITH, Adrith Mahesh. And it's a nice... some nice calculations, arithmetic here and there. Some hard... differentiation there. Imaginary number, is that? Oh no, it's sines. I thought it was IM. Sine, cosine, a secant. Yep, square, minus square stuff. By the way, this one is interesting. So it's saying sine 75 degrees plus secant 15 degrees plus sine 15 degrees, secant 75 degrees, like this squared, and then minus this one. So this one is interesting, so I'll just solve this one here. Sine. And secant is just 1 over sine. And then square that. Plus sine 15 plus 1 over sine 75 squared, and then minus, what is it, 1 over sine 15 squared, and then sine 75 squared, because it's this whole thing is squared. And now I think how we solve it is sine 75 degrees, because 75 plus 15 is 90. Sine 75 is equal to cosine 15. So we can change that there and there. We can also change it here. So this equation becomes cosine 15 squared. I'll just write C. Cosine 15 squared plus cosine, this times 2, which is 2 cosine over sine. And then we also have sine 15 1 over sine 15 squared. And then we have what is it? Sine 15 squared, and then 2 times sine divided by cosine plus 1 over cosine squared, and then we minus 1 over sine squared cosine squared. Right. Goodbye, Trizubni. Everyone is typing fish. Okay, thank you. So, if you know trigonometry identities, you know that this is 1. This one, you have to combine them and get this, which is, again, this just becomes 1. And look how it cancels out with this one. So this cancels out like that. And here, we also have 2 times SC. Make them go together, we get this. And this is also 1. So the answer is 1 plus 2 over sine 15 degrees times cosine 15 degrees. And if you know another kind of trigonometry identities, you know that 2 sine theta cosine theta is equal to sine of 2 theta. You divided both sides by 2 and you get this. Which means this thing is half of sine 30 degrees. And sine 30 degrees is what? Half, right? So... okay, maybe I'm wrong, because I just got 9. Maybe I was... some of these calculations were wrong. Anyway, I got 9. Maybe I'm wrong. Okay, let's just try Wolfram Alpha. Wolfram Alpha. Wolfram Alpha. Sine 75 secant 15 squared. Sine 15 secant 75 squared minus that. So it's this minus 1 over sine 15 degrees. Was it sine 75 degrees squared? Wait, it's 5? Okay, maybe I was I don't know. I don't know where I went wrong. I don't know where I went wrong. Huh. Oh, secant is... Wait, secant is 1 over cosine. I'm stupid, actually. I'm actually stupid. That's true. Right. Okay. Then it's 5. Then it is 5. Okay. Right. What else do I have? Well, we have one from Tim. Is this one? Oh, wait. What's the clock? Yep. Which would also had like... wait, we solved this one. Okay, this one we solved. Which one is? I'm looking through all my emails. Owen. We saw that. I saw that one too. Something. Bam, bam, bam. Huh. I'm breaking. I am bugging out. I'm bugging out in real life. We have one by... What is this? Which one? Wait, we have one by... Wait, I can't find an image. Where is it? This one is by Abhinav Gupta. Wait, I can't even open the image in a new tab. Right, now it's loading. It's a nice arithmetic clock. Wait. Okay, they also have another version, which is this. Nice arithmetic clock. Some pi with square root of 7 and floor action going there. Some double factorial going down there. So, yeah, thank you for submitting. And I think... we also have one by Darren Wu, which is a nice unit circle. It's not 1 to 12. It's not an hour from 1 to 12, but it's like showing all the points that are like 30 degrees, 45 degrees, 60 degrees from the x-axis. The first quadrant, all the 4 quadrants. Yep. This is the angle in radians. This is the coordinate. Bam, bam, bam. Nice. So, okay. Thank you for submitting all the clocks. If I missed anything, I'm sorry. I cannot go through everything here. There are some submissions are not through. There were some submissions neither through email nor through the YouTube community page, and I cannot remember all the links of the submissions there. But so the late submissions section ends here. It took 46 minutes, right? That's about how long I thought it would take. Okay. Pinkish Nova, 9 o'clock is wrong. Wait, Pinkish Nova... Your clock is the hard one. Okay. You can make it to solve the right thing. Make it so once a toad or from jumps, they remove the tile they jumped from. Toads. So your clock says toads to start, and I'm not sure how to interpret what you just said. Toads to start. Okay. Whatever. Okay, I'll get to that because your clock is the final clock here. We are gonna start from 241. Wait. 예피 없어졌나요? 이메일로 보냈는데 없어졌나요? 혹시 이메일 이메일에서 이름이 어떻게 되시죠? Okay. So now the real thing starts. Now it actually starts. Okay, now we can actually start. And today, the theme of today's stream is redemption. What do I mean by that? So first of all, last time I miserably failed at a few questions. Here's one. This is a code I wrote live in the last stream to solve one problem in Number Basher's clock. And it failed miserably. And I titled the name of the file fraud.py because I was a fraud. But now, in my free time, I have debugged the code through my own willpower. So I've become unfrauded. Unfraud.py. What was the problem? Number Basher's clock problem. How many 2x2 squares can be placed to fully cover a 10x10 grid where each square is occupying at least one cell which is not occupied by any other square? Let's change the font size to 24 or something. And I hope you can see it now. Okay. Oh, by the way, I see I missed one submission from my email, so I'll look at it right after this. So this one, I've programmed the solution to this with dynamic programming, and this is how it looks like. And let's run it. Bam. As you can see, it just ran. Here's what it gave out. Wait. What did I just... No. What did I write here? Bam. Wait. What did I... Bam. Okay. Oh, I'm supposed to put 9 and 9 here. So I've made a code that like generalizes to any row or column, but it takes a long time, so it only works up to row 10, column 10 or something. But if we start, you don't have to, like, I'm not gonna explain what the problem is, but the answer is printed out here, which is 39. And this is the geometric solution, and what it looks like is this. This is how it looks like. This is the solution to make how to cover a 10x10 square with 2x2 squares, so that if you remove any of the square, you get at least one cell missing. So if you remove this, you get cells missing. If you remove anything like this, you get a cell missing. So this is the solution with the maximum number of squares. This has 39 squares. So that's how I solve this problem by Number Basher, and I have unfrauded myself. And by the way, here is one. Here's a okay. Bam. Here is one clock from Yippee. Bam. And very normal clock. Some nice arithmetic and some crazy university math. Some derivatives, partial derivatives, and stuff. Crazy calculations. This is definitely in the very hard clocks if I were to solve it. Anyway, thank you for submitting this one. Amazing. But I guess we are now moving on from late submissions to the how many are there? 16. The 16 final submissions of the Math Clock Contest 2026. Let's start from Adacy or Adaki, I'm not sure. Adacy's flag, which is this one. Time to lock in, right? Okay, it's not that hard. It doesn't look that bad. Let's look at it. 2 to the... Oh, why is it so thick? 2 to the 0 times 2. That's just 0. Right? 0. 2 to the 0 is 1. So 1 times 6 is 6. Maybe. Maybe. And then we have 2 base 0 to 6, so that doesn't matter, it's just 2. This pi means the prime counting function. Prime counting function, how many numbers are prime that are less than or equal to 2? Well, 2 is prime, so there's one number that's less than or equal to 2. That is prime. Bam bam bam. Oh, it's 0 times 2 and 2 times 6. That makes more sense. So it's just 0 times 2 equals 0, and then 2 times 6 equals 12. Right? X2. X squared? The yellow things on the background look like... They look like dice. Or, not really, but... There are the number of dots. Nathan is usually pronounced arithmetic. Air? Really? Arithmetic? 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 Arithmetic. Wait. Arithmetic. Which, so it's either one of the two? Arithmetic or arithmetic? Arithmetic. Okay. Anyway, what is this? Maybe it's matrix multiplication? Maybe it's square this matrix? Which would give... Arithmetic. Which would give... I don't know, 4. It doesn't look like that's the answer. It's like... Not sure how to solve this one. Z... Empty set? Z6? Size. Maybe what these things mean don't matter. Wait. Maybe it's just the size of a set with 3 elements, so it's 3. And this is just an aesthetic for 2026, maybe. Maybe it's a set with 3 elements. Arithmetic. This is the... Wait. This is the... What was it called? Not deformation. D something. But anyway, it's the ways to order two things such that none of the things are in order. As in, you need to order them like 2 and 1. This is the only way to order them so that it's none of the things are in the correct place. Subfactorial? Right, subfactorial. So this is 1, which means the diagonal of this is 2, which means this diagonal is 4. Here we have 202 in base 6, which is going to be 72. 72 plus 2, which is 74. Mod that with 20 plus 3. 23. Which is going to be 74% 23. This is 74 minus 23 times 3 is 69, and that results in 5. 예피님 서팩토리얼 다른 걸로 압니다. Derangement. It goes like this. So, subfactorial of 2 is 1. Bam, bam, bam. Goes like that. We have 0 squared is just 0. And then I guess this is 0 tetrated, 2 tetrated to 0. 2 tetrated to 0, which is going to be 1. So 6 to the 1 is 6, maybe. That's how it works. We got 7 with 2 and 6. 2s and 7 with 2s and 6s. Trace of a matrix. It is the sum of these two numbers, which is 8. What is this? Oh, the area of this. I think it's saying this is like part of an equilateral triangle. So this is going to be 60 degrees. If this is 90 degrees, and that means this is 30 degrees, which is going to be is that true though? I guess it's saying this is 30 degrees and this is 6. Which is weird because then this is 6 divided by root 3. So the answer of the gray area is gonna be 18 over root 3. I think maybe it was meant to be... I'm not sure. Oh, wait. By the way, I missed a donation again. I'm stupid. Thank you, Ralph. With Ralph W. Dissociation. Ralph W. Dissociation. Thank you for the donation. Fish stream. Thank you. 6 root 3. The area is 6 root 3. And then here we have 2 factorial is 2. 0 subfactorial is still 1. Just like 0 factorial. 2 subfactorial is also 1. 6 subfactorial is 265. Okay. So 2 minus 1 just removes that. 265 in the numerator. We have 2 plus 0, 3 to the power of 3, which is 27. I guess this is the round function because this is almost 270. So if you divided this by this, it rounds to 10. Number of grams of phosphorus in 2,226 raw macadamias. Macadamia. Amount of phosphorus. Amount of phosphorus in macadamia nuts. Wait, just continue. How much? Ranging per 100 grams. Wait. How much does macadamia weigh? A macadamia nut weighs an average of 2.6 grams per unshelled kernel. 2.6? 198.0 milligrams per 100 grams. So, what are we calculating? Number of it in 2026 raw macadamias. This should be a raw macadamia, right? Number? Wait, there's a calculator? There's a macadamia nut calculator? What? We have a macadamia nut calculator. Number of macadamia nuts in your portion, 2026. Weight of one average macadamia nut in grams, 2.6. Total weight of your portion. Please enter only digits. They programmed the HTML wrong. They made it so that there's only... Okay, they programmed it wrong, but it works. Total weight of your portion in grams is gonna be 5,267.6 grams. So... So what do we do? That's right. And 100 grams. This per 100 grams. So, oops. Times, divide by 100, and multiply it by, let's use 198 maybe. And that's milligrams, so we kind of have to do 0.9198. And that gives 10 point something grams of phosphorus in 2026 macadamias. Maybe if I choose like a larger macadamia, like a 3 gram macadamia, then maybe it becomes 11. Not 3, but maybe 2.7 or something. Yep, and that kind of becomes 11. Right, and that solves the clock. Thank you, Odyssey, for submitting that clock. Bam. Wolfram Alpha might actually have nutrition facts. Really? Really? Macadamia nutrition. Wow. Phosphorus 6%. Okay, maybe that's what we're supposed to use. I mean, wait. 6% is a 6% of the daily value, right? 6% of daily value. Yeah, right. 6% of daily value. How much is a daily value? Phosphorus daily value of I'll just write that. Nah. Daily value nutrition. Nutrition. Give me something. Phosphorus prize. Unfortunate. I mean, it has to be that 6%. 6% number. Oops. I mean, anyway, it makes sense. It makes sense. It was almost 11 grams even if we calculate it in other methods. So yeah, that makes a lot of sense. It's 1250 milligrams. So we do this. Okay. I'm not sure. But the calculation was not wrong. So I am satisfied with that. The next one is by Hugo Colas. Bam. It's a music-themed clock. And the alternative pianist. Wait. Are you Hugo Colas? Hello. So, we have some base 3 kind of encryption here. Let's try decrypting all these stuff first. So, in order to decrypt, we need to divide the code into sections of 3 letters. So let's just do all of that first, so that I will not make any mistakes. I'll just like put lines between every 3 letters. Bam, 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 bam. By the way, okay, I can kinda 1 to 26. So if I turn it into base 3 in my head, and if I'm smart, I'll be able to do it in my head. But it's hard. This one is like 660. That's gonna be 18 plus 6, 18, 24. The 24th letter of the alphabet is X. Is that how it works? 660 is X? Right. This is space. Space. 200. That's 9, so it's I. Which means, no, it's I. The way we are doing it is, first, like if you have a number, first you change all the 2's to 1's and then 6's to 2's, and then you interpret as base 3, which means you multiply this times 9, this times 3, this times 1, and add them up. So here, 260 will be 9 plus 6, which is 15. And that will be the 15th alphabet, which is O. O. Like, O. Right? Okay. 602, 2 plus, 1 plus 2 times 9 is 19, which is going to be S. 000 is a space. 122 in base 3 is going to be 6 plus 9, 15 plus 2 is 17. Is Q. 210. 18 plus 3 is 21. 21st letter is U. The second, that's 1. The first letter of the alphabet is A. 211. 1 plus 3 plus 18 is going to be 22. Its 22nd letter of the alphabet is V. 026, 012 in base 3 is 5. Wait, maybe V... What? Quaver? Yeah, quaver. Quaver is a quarter note, right? Quaver. Wait. Quaver. What's a quaver? No, quaver is the 8th note. Okay. Quaver is the 8th note. Okay. X is quaver. Crotchet? Where it decodes to quaver, in reality it's crotchet. Wait, what's a crotchet? Crotchet. Crotchet is the 4th note. Okay. So error. It's actually supposed to be crotchet. Bam. Okay, let's move on to BA600 is R. QRS bars. This says bars. So okay, I believe each of these hints are there to solve each of these problems. So let's solve 1 o'clock first. And obviously it's saying X is crotchet, so this is just X, but like that, we know how to do that. Pi divided by 2 times 2026. Really? Cosine. Okay, so what we're supposed to do is do a little bit of substitution. Substitution thing. Let's do that. And like, I don't know, like, yeah. This is how it works. So this is equal to, change this to U. Change dx into du divided by 2026, so that just becomes this. And then we have, when x equals 0, u has to equal 0 too. If this is x, then u is supposed to be pi divided by 2. And this is just gonna be 1. So that is why this is 1 o'clock. We have bars for 2 o'clock. Let's see. 1, 1, 1. Maybe we count how many bars there are and divide it like that. Okay. So how many bars are here? We go 1, 2, 3, 4, 5. And then we repeat. So we return to the first position. We go 6, 7, 9, 8, 9, and then we skip this part because we already been there for the first time. Here's where we go for the second time. So we go 10, 11. So we are up to 11. And now there's another repeat sign. So we return to the first position. And then we go 12, 13, 14, 15. And then we skip 1, we skip 2. We go to 3. 16, 17, 18, 19. So we are up to 19 right now. And then it says DC al fine. DC da capo al fine means we return to the start. And then we end at fine. Okay? We end at fine. So we return to the first part and go 20, 21, 22, 23, and like this is hard because oftentimes when you do da capo al fine, you don't repeat while you are doing the da capo. So maybe we are supposed to just go here like 24, 25 and end. But I guess this doesn't really fit that description, so maybe we just go 24 and then go again. 25, 26, 27, 28, 29, 30. So we end at 30 when we reach Fine. So I think it's 30. And in the numerator. In the below, it's gonna be 1, 2, 3, 4. Repeat 5, 6, 7, 2, 8, 9. This is not a repeat. This goes on. Just goes 10, 11, 12. Repeat back to here. 13, 14, 15. So it's 30 divided by 15, which is 2. Okay, for the next one, let's decode this first. Let's see. 606 is gonna be 2 plus 18, which is 20, which is T. 100 I. 222. That's gonna be 9 plus 3 plus 1. 13. M. 1, 2, that is E space S I G 112 N A 202. 18 plus 2 is 20. That plus 1 T U R E. Time signature. Bam. Let's see. We've got 4 beats here. Like, do I write it as 4 beats or maybe I'll just do fractions and calculate everything later. Dotted 8th note is 3/4 of a quarter note. I'm gonna count everything in terms of quarter notes. Okay, that's 3 quarter notes. This is half of a quarter note. Is that the double whole note? There's 2 lines and 1 line. I guess they are the same thing, right? I thought they were different, but maybe 2 lines and 1 line. Second longest. That's the longest. Okay. So it's twice the whole note, which is 8. But then there's a dot, so it's 8 plus 4, which is 12. Whenever there's a dot, you multiply it by 1.5. And whenever there's 2 dots, you multiply it by 1.75. So here's 1 plus half plus a quarter. That is this. This is gonna be 7 over 4. And then this is gonna be 2 plus 1 plus a half, which is gonna be 3 plus a half, which is 7 over 2, right? Here we have this and this add up to 1/16. That together with this add up to 1/8. Okay? Divided by, okay, so let's calculate that. Let's see. I'll guess I'll add this first, which results in 5 over 2. Add this together, which results in 4. Add this with this, results in 3. Add all of that. 4, 3, 3, 10, 22, 26. 26, maybe. Unless I've made a mistake. Maybe. 4. 3/4. quarter, whole tone, whole note, another quarter, that's quarter of a quarter, 2, dotted eighth, 1, 2, 3, so that's a 16th. Together with that, that's an eighth. Together with that, that's a quarter. Add them all up. This is a 1. 1, 4, 1, 6, 7, 8, 9, 10. So I think what the aim was to put 26 and a 20. 26 and 20, if it's in 8th note, it's going to be 28th notes. So anyway, that's how 26 and 20 is integrated. And there is a ceiling function there. So 26 divided by 10 is 2.6 times, ceiling that is 3. Let's take a look at our number 4. This is going to be B-I. 9 plus 3 plus 2 is, we did it here, N-A-R-Y. Binary. Chords from C4 to B4. Times chords from C4 to B4. Not sure what it means by chords from C4 to B4. They are like, if you're talking about notes from C4 to B4, then there are 12. C4 to B4. Okay, there are 12 notes from C4 to B4. Okay, C7 minus C sus4. How would I interpret that? Is there a way to enable closed captions? YouTube is making it very hard to follow this stream without audio. Right? On this stream or on the uploaded videos? Because on the stream, I am currently on a very short latency mode, which doesn't allow closed captions. For our number 4, consider chord extensions as being in the same octave and in descending order. C9 is right. Okay, let me play some piano for you to illustrate this. So C9 is technically it's B flat. C major 9 is B. So anyway, I have piano set up. Tone down the music. Also, only count natural notes, white notes, not accidentals, black notes when decoding. Accidentals will be converted to natural notes. Okay, so C9 is C, E, G, B flat, D, but accidentals will be converted to natural notes. B flat, flat gets removed. So C9 is that's the C9. So let's see. 2. Haha. Did you get it? C? Okay. 2 times C7 is gonna be B, G, E, C minus C sus4 is G, F, C plus let's look at the rules again. Right, I think that's correct. I think, yeah, I think this is correct. 0, C9. That's a D. Plus C7 says 4. Divide that by. But like, does this even matter because it's a 0? I don't know how arithmetic works, so I'm just gonna write them all down, right? C7 add 11. That's gonna be B, G, F, E, C. Minus C6, A, G, E, C. Chords from C4 to B4. How? Binary. Oh, wait. Okay, I'm supposed to turn that into binary. 1 0 1 0 1 0 1 because it's C, D, E, F, G, A, B. Right? Okay, let's first write them down. 6 times C plus, that's G, E, C, plus C sus 2. Okay, sus 2. I guess it means G, D, C. I guess. Okay. I guess. Right? Now let's try the bottom. No, let's just calculate this in binary first. GFC is going to be 11001. Because, no. Yeah, we are supposed to start from C, right? Yeah, C is the last, not A. C is the last digit. So this is 1, C, D, E, F, G. C, D, E, F, G, A, B. C, D, E, F, G, A, B. Right? C, D, E, F, G, A, B. C, D, E, F, G, A. C, D, E, F, G. C, D, E, F, G. Calculate all of that. Do I compute? Okay, I'll just turn them into decimal. 1 plus 4, 5. Like, this is 1, 2, 4, 8, 16, 32, 64. That's gonna be 80, 84, 85. 85. 85 minus 25, which is 60. Plus 0 times doesn't matter, right? Because this is actually just arithmetic. We have this is 64 plus 16 is 80, 88, 92, 93. We've got 48 plus 5 is 53 is 40. 2 times 40, okay. Here we have 5 plus 16. 21. 3 plus 16, 19. Add them up, we also get 40. So this is 120 divided by 80, 320, which is 3/8. Okay. Let's go. Let's try this. We have 2 times 0. We just remove that. 2 times C7 says 4. Did we do that here? It's here. C7 says 4 is... Oops. 1, 2, 4, 8, 16, 32, 64, 89. Right? 89. That's C7 says 4. Minus C2C says 4. Actually, I just could have done C says 4 is GFC, so that just only leaves 2 times B. So it's 2 times 64 divided by 6 times C minus C says 2. C minus C says 2 is just E minus D, which is 4 minus 2, which is 2. Right? This is like this. This is it. Okay. And the answer is this times this, so it is 4. Now let's go 5 o'clock. Bam, 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 ba, ba, ba. E, R, R, Q, R, S, T. U. That's a P. Wait, 9 plus 6 plus 1, yeah. Tupper? Tupper. What's a tupper? What's a tupper? Also, wait. Music. Tupperware. Tupper box. Tupper. That's a tupper. For y equals 4166806. This is 10. So this is just 41660 times 2 to the what? 2 to the what? So we have x here. Mod. Search for Tupper formula. Oh, right. Right. Right, I've seen this from Matt Parker, I think. Who was it? I think it was Matt Parker. I've seen this from, maybe it was Numberphile. Yeah, I remember this. It's a self-referential form. It's a function. It's kind of not a function. It's a set of points on the graph that just contains every single possible picture. Yeah, period. It's just every single possible picture. Just a pattern on the 2D plane that just has every single possible picture. But the thing is, we need k equals number options. No, it can't be 17. Where do I change the 17? Where's the 17? I need to change the 17 to 10. No, wait, is it 10? Wait. No, I have to change a lot of numbers. Minus 7x minus mod y. That's also 7. Also, oh right. This is 7. I need to change all of them to 7. 7. How would I? Maybe Desmos. Right. Huh. 7. Chain y equals 4166806. Wait, I need to change it here. Right? But I don't know how to how to move to this point. I don't know how to move to that point. Okay. Okay. How do I do that? I could do this. I could do this. 4 1 4 1 6 6. Aha. Wait. Turns out I only zoomed in the y-axis. Okay, it's not calculating. It's not calculating. No, it is calculating. I was just stupid. It's a 5! Wait. Right. So this graph just contains all the possible combinations of pixels in a like infinity by 7 grid. And if you go up to this specific number, you get 5. Five. 6 o'clock. 6 o'clock. We have P U L S E S pulses. Wait. Right. Pulses. Wait, what's... I don't actually know what that means. Rest Music. Rest duration, maybe. Rests. That's a breathe. Okay, that's 2. That's a 2 measure rest. 2 measure rest. Double whole rest. Two measures. Because this measure contains 4 half notes, so the entire thing must be 2 measures. I mean 2 whole notes long. Quarter notes divided by quarter notes. I don't know, I guess I'll just add all of them up. 2 measures. So it's gonna be I'll write them in quarter notes. 8, 8, 8. This has 3, 3, 4. This has 1. Which means the entire thing is gonna have 8, 16, and then return. Then go 24, 32, 40. And then we go 43, 46, return. 49, skip 1. 53, 54. Divided by. That's just 1.25. So how will I write that? I'll just write this. 5 over 4. 5 over 4. 3 over 2. 3 over 2. 7 over 4. 1 over 2. Add them up. Bam, bam. So at this point we get 5 over 2. We return. We have another 5 over 4. So let's just write it like this. Plus 5 over 4. Plus, and then we skip 1 and go to 2. We have this and this, which is 3. Plus we have this and then this. So we just do that. This ends up being 12 over 4. So 3. This is also 3. So this is 9. Divide is 6. Okay. For the next one, we have x space x the I s space q. And I guess that's another quaver. But it's supposed to be... yeah, it's supposed to be a quarter note. And we just calculate this. 7 times 2026. 1 minus x to the 25 dx. So... this is just a derivative of minus 7, 1 minus x, I mean 2026, right? Yeah. Input 0 and 1. If we put 1 to x, then it removes 0 to x, then it becomes 7 times 1, so it's just 7. That is just 7. Next up, what is this? 602 is your S. 620 is U. This is M. Sum. Sum of. This is equal to 2. 2 plus 2 times 1 plus 3 times that's a half. So 4 times a quarter plus 5 times an eighth plus 6 times 16th and so on. What is this equal to? Now, when we want to solve this, I think it's better to look at it like this. So, imagine you have a 2, and then you have 1, 1, you have half, half, half. You have quarter, 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 quarter. You have eighth, 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 eighth. You have 16th, 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 and it just it's a triangle. It just goes on forever. It just goes on forever. Now, if you know anything, if you know about these like infinite sums, you'll know that this adds up to 4, right? This adds up to 1. It's just like 2 plus 1 plus half plus 4th plus 8th plus 16th. Right? So it's 4, 2, 1, half, 4th, 8th. And this goes on forever again. So this now adds up horizontally to 8. So that's 8. You're making fun of my 8th? That I did it as a bit, you know? I don't actually pronounce 8th as 8th, right? 8th, 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 8th. What? A. R. E. Area. Right? Read it that way. Area. Just multiply them and times pi. Divided by 4. So multiply them, we get, this is 2 root 12 times root 27, maybe? Is it? Yeah. We are supposed to multiply this by pi and divide it by 4. So, pi gets removed. This is 2 root 3. This is 3 root 3. This gets deleted. So all we have left is 3 times root 3 times root 3. That's 9. 9. Next, we move on to 6. 6 is what? N. N. E. W. T. 9 plus 6. Newton. 3. Wait. Is that? No, that's not 3. Wait. What is that? Newton. What is that? Is that like a notation by Newton? No. Well, this is 5. What is this? Is this actually just 6 over 2? But there's no way this is... Okay, coefficient of x to the 8. When? That's that's just this. Wait, there's no coefficient of x to the 8? Wait, what am I missing here? Something times the coefficient of x to the 8. Newton binomial expansion. What? Newton binomial expansion. What's a Newton binomial expansion? Oh, the generalized binomial series, maybe? Maybe it's this? So it's supposed to be plus RK. We need to pick x 4 times. It's like this. Maybe that's what it is. Yeah. Coefficient of x to the 8 is I think it's this. Is it? I think it is this. Plus. That's a... we have 8 times 3 to the 5 in the denominator. And here we have minus 80. So we have minus 10. That times this. And that's 3 to the 5. So that cancels out with this. And all we have left is 10. Right. For 11 o'clock, we have... E... N... F... Wait, no. C... R... Y... P... T... Oh. Encryptor. We have encryptor. What is the floor of the percentage that a 4-letter word that can contain a space contains 2026 at least once if the word does not contain duplicate letters? Oh, 4-letter word that can contain a space contains encryptor 2026 2026, but that's 4 digits. Oh, right. I guess it means we are supposed to change if it's A, B, C, D, we are supposed to change it into 00200602 whatever it is, 022. And then what is the percentage that this contains 2026 at least once? So let's think about a few cases first. It's a 12-digit string, but it cannot contain duplicate letters. For example, there are 12 digits, so it can come in the first place. It can do something like this, right? The letters we pick could be this. But the problem is it cannot contain duplicate letters. So the way I'm gonna approach this is I'm just gonna count everything and not think about duplicate letters first. And then after I do all that, I'm gonna subtract the number of cases that have duplicate letters. Okay? So here's how I'm gonna do it. If it's for all possible cases of 2026, just not accounting for duplicates. Okay? So obviously we have 12 blank positions. 2026. Where can 2026 go? It can go all in here. It can go in here. All the way from here to here. How many possibilities? It can start from here, 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 It can start from 9 positions. Right? The way we can think about this is just think of this as a single unit. If we think of it as a single unit, how many letters are there left? There are 8 letters left, right? So in essence, we are trying to find the number of ways we can line up this single unit of 4-digit number and 8 other digits. Now, once we choose where our 2026 will go... Oh, wait. Okay. Technically, it's harder to do it this way. But maybe... Okay, it's kind of harder to do it this way. I'm thinking of a way to explain it in the easiest way possible. But I can't think of a way to do that. Let's just do it like... I don't know. Well, there are 9 possible places that 2026 can go. Right? And then once we do that, all the other digits can be one of 3 possibilities, 0, 2, or 6. So it's this. Now, what if there are more than one... There's more than one 2026. Okay? More than one 2026. Like, there could be 2 2026s. Something like this. Something like this, right? And like one... how do I do it? At least 1 2026. We're going to subtract the case of at least 2 2026s from that. And then we're going to get exactly... wait. This doesn't matter. Wait, this approach doesn't work. Let me think of it. Let me think about it for a second. It's kind of slow because I'm not thinking in Korean. I need to think in Korean. I need to think in Korean for the speed. Well. Problem is, if I do this, this accounts for something like this 2 times. And it accounts for 2026, 2026, 2026, this string of letters 3 times. So what we need to do is subtract the case of at least 2 2026s. Which is gonna give me 2 sets of this plus 4 other digits, which is gonna give me how many ways can I place it? It's 6c2 times 3 to the 4. I'm not gonna explain why all that. It's that I'm just gonna try and get the right answer. This is 15. And we need to add a case of 2026, 2026, 2026. One case. Right? And then we need to subtract what? There cannot be duplicate letters. So bam. 2, for example, we cannot have something like this. Let's think about all the things that cannot happen. So, how about this? Or this? Uh... Um... Huh. Wait, this is actually really, really hard. Actually hard. User 2 can be anywhere. It can also be overlapping with the 6. If you have 202, there could be another like something like that, whatever, and that doesn't work. You can also have something like this or this, and that doesn't work. Which is take the word as 27 times 26 times 25 times 24, as there cannot be duplicates. Now center your focus on letters and not the positions. Oh, right. Center your focus on letters and not the positions. So, 3 possibilities starting in 202. X20 or XX2. So if it starts with, yeah, if it starts with 202, what I need to think about is, okay, so first of all, it can go here, here, or here, right? And I think it's really challenging because, like, yeah, this, let's pick this letter first, which means there are three to the 2 possibilities, right? You can pick this one and this one. Now let's say we've picked that one. Right? And now let's look at this one. This one cannot be this or this. So this can only be one of 25 letters, and this one can only be one of 24 letters. And the same thing works for this and this too. Right? Yeah. And there are three such cases. But there's a problem. What problem? Because after this, we are going to like consider the case of 2026 like this, right? In this case, we can have 2026 here, here, or here. We pick this letter 3 times. We'll pick this letter 3 times. Let's say we pick that letter 3 times. We pick this letter 3 times. This cannot be this or this, so 25 times 24. And the same thing applies to these, so it's that times 3 as well. But there's gonna be a problem, I think. Okay. How do I... Now we need to account for this, right? And it can go in one of 3 places. And we already chose this one. We can choose whatever 2 numbers for that. 3 squared times 24 times 24 again. And 2026 can be here, here, or here. So it's times 3. But now we have all the cases of this, this, and this. But the problem is we counted some of them twice. Some of them even 3 times. So, for example, this instance was counted both here and in here, right? So we need to remove cases like these. Cases we need to remove are this, yeah, don't count that. Yeah, we shouldn't count this because we've counted these twice already. So adding these up is not the answer because we counted these twice. So we need to subtract these again to get the correct answer. So bam. You didn't consider that, I think? Huh. I thought so. I knew what... Okay. I realized you didn't consider this because you were saying that this is a much easier way. Because I was thinking it was going to be as hard as... Anyway, I thought this method was as hard as this because of these exceptions. Yeah, because there can be more than one 2026. And yeah, the problem is there can be more than one 2026, but the problem is we counted them twice in here and in here. So we need to subtract them once to get the correct count of the number. But I think even if you didn't consider it, it's not going to matter like that much. I guess the percentage will only be like 1% off or something, because I don't think it's going to be that much of a percentage. Okay, whatever. If we don't consider that, then the answer is 26 times 26 times 25 times 24, and on top we have 27 times 25 times 24 times 3, which cancels out really nicely into 3 over 26. Three over 26. Yep, and that starts with 0.0, 0.11, 0.11 percentage. X-intercept, and the final, for the final 12 o'clock, we have, what's this? N, O, space, H, just no hint. X-intercept of y equals x squared minus 12x. And that's gonna be 0 or 12. And that solves the music math clock. Amazing, amazing clock. Thank you for this submission. Yep. Thank you, Hugo Colas, for this submission. Okay. Amazing. Amazing. Bam, bam, bam. Okay, I'm gonna drink some water. Be back in a minute. Back in the studio. I don't have a studio. Okay, the next clock is by Matthias. They told me how to pronounce their name. I think it was Matthias. Sorry. Okay, I think it I'm sorry. But here is their clock. Right? This is their clock, I think. Bam. Oh, good night, Hugo. Now, it's not that hard, actually. Pretty doable. It's pretty. This one is pretty easy, I think. We have 86 divided by 86, which is 1. 1 plus 1 is 2. I think this got into the final few because Matthias had a clock that was technically like... Oh, I think this was technically a late submission, which was why it got put in here. But I forgot to group it with other late submissions. So, okay, whatever, let's look at it, This is 1 divided by 1. 3 times that is 3. 4 by, that's 2. Times 2, so that's 4. 12 divided by 6. 2 times, so 12 divided by 6 is 2. Times 2 is also 4. Right. I cloned Zai while he was sleeping and made Zai pizza. So this is a pizza. This is not a math clock. This is a math pizza, I suppose. Also, there's a 2026 here. 20, that's gonna be 42 minus 2 is 40. Plus 20 is 60. Divided by 10 is 6. That's 77 over 7. 11 minus 4 is 7. What is that? Is that 13? It's that, I don't know. Maybe it's a... Is it a 3? Because this cancels out. I think it was originally written as 3, but then they rewrote 1, maybe? Because then if you multiply it by No. Multiply by 2? Okay, so I don't know what this is, but it has to be 4. Because then if you multiply it by 2, you will get 8. Oh, right, it was B. And this is what gave us B. Okay, it's 5, 3, 4. 4. So B is 4. And then times 2 is 8. Okay, that solves. 6, 5, 6, 1. I believe is 3 to the... What is it? Is it 3 to the 9? 3 to the 9, maybe? No, 3 to the 8? It's 3 to the 8, right. This is 3 to the 8. Square root that, we get 3 to the 4. Square root that again, we get 3 to the 2, which is 9. We have mm divided by cc. What? Oh, right. just 2000 divided by 200 is 10. Keyboard. Down, right, times 2. Keyboard. Down, right, times 2. Okay, if you go down and go right, what is it? Maybe you start from like at the top left corner of the keyboard. Then like there's the escape key, right? And then if you go 1 down, you get like the backtick something, you know, the tilde. How is it written? Like it's like, is it like this? And then you go 1 to the right and you get 1. The key of 1, right? Maybe that times 2 is just 1, 1. So that's why it's 11? I think. 7 plus 5, 12 times 68 divided by 68. So that is 12. And that solves the clock. Thank you, Matthias, for submitting that clock. And, wait, I forgot to delete that. We are going to move on to Meister? Meister. And Meister actually wants me to read through this document, which is, how long is this? 12 pages long. Exactly 12 pages long. That's amazing also. I don't know if you planned for having exactly 12 pages. Okay. It looks very hard. I don't know how to solve any of these. Welcome. I am writing this document since my clock might not be the most self-explanatory. Originally, I intended to make a video about it. However, I realized that the proximity of my exams is a bit too low to finish that in time. If Dr. Zai's math clock contest, everyone knows it, so everyone knows it in the chat, so let's move on. The idea. Both math and speedrunning. You can certainly recognize the direct correlation between a clock, time, and speedrunning, of course. However, how on earth do you combine such a long, enduring, thought-based activity, mostly with pen and paper, with one where once on a good pace, you'll nervously press with shaky hands on your keyboard to make fast and accurate inputs in a video game? Well, this is essentially my attempt in doing so. To be able to do so, we should probably concisely define speedrunning first. The top 4 of any percent NMG in Will You Snail? Wait. Okay. So Meister is top 1. Wait. Will You Snail? I know the game Will You Snail by Jonas. Yep. Number 1 in Will You Snail any percent NMG. No major glitches. Amazing. Amazing, amazing. Will You Snail world record. Yeah, that's a speedrun timer. This is also a speedrun timer. Okay. Back to where was I? Definition: speedrunning. You have some sort of game with a certain set of goals, usually a completion of the game, when you try to finish as quickly as possible. Right? Individual segments. Game rules. The individual levels of the game are mostly arithmetical equations. However, absolute standard equations pose the problem of a binary nature. Either you've found a solution or not. It's often difficult to find an objective measure to determine better or more elegant solutions. That's why solving the equation will be the equivalent of beating a level. To determine a time, I came up with the concept of Xi sequences. In case you shouldn't be used to mathematical notation, don't be overwhelmed by it. I promise the simple intuition will be outlined immediately after verbally as well. First of all, let lambda be a finite set of mappings, arbitrary finite amount of variables. Then define the following sets: lambda prime, lambda union, all the lambda k, where lambda delta is lambda k, where k is a natural number and there's a lambda delta in big lambda, such that. Okay. So it's just a set of all the lambda k with, wait, what are p prime 1 to p prime n? What's p prime 1 to p prime n? Lambda equals a where epsilon is in a, and all lambda of this. Okay, I want to know what lambda, what small lambda is. Small lambda. Okay, it's a symbol. Small lambda is a symbol that can be expressed with conventional mathematical symbols with their corresponding standard interpretation, and a dot wherever a parameter can be inserted. Examples. Something. Okay, that's a mathematical expression with a dot wherever a parameter can be inserted. Inputting an epsilon is the equivalent of just removing the dot. Sometimes that's defined as well. Wait, this is also a parameter? I think... Wait, but wouldn't this dot... Wouldn't it just not matter? Is it just not just the same as writing x dx? Or maybe, right, all the dots can be different, so that's why they are dots. Maybe it can be x squared dx or something. Usually, and in every level of the clock, you want to allow to insert before or after the symbol anywhere. So therefore, okay. Okay, you can insert symbols anywhere. So let's return to the clock. So what you're saying is, we are supposed to insert some symbols here and here to make it this, maybe to make it correct, or maybe okay, let's read further. I'm guessing lambda is that notation, and p1 to pn are gonna be the variables we put in that notation in that order. So p1 is gonna go in the first dot, pn is gonna go in the last dot. Lambda prime is every... But, like, we didn't define p1 prime to pn prime yet, right? Right? Okay. Again. Epsilon in A. Where all lambda is in lambda prime. All A1 to AN is in big A. That is in A. Okay. It's hard because it's... the explanation is too concise. I kind of wish there was... Have a good night. all hey, lambda prime is only a symbolic placeholder for later, so that's this so that the sets don't actually include the evaluated results. Lambda prime. What? Yeah, what's lambda prime here? How are the colons... Wait, what are the colons doing here? Also. Is it just... Is just another and sign? Maybe? Maybe. So we have an expression... Okay. An expression with variables. And then the xi symbol. It's a function that goes from this to this. But what is this? What is this? It goes from this to this. Complex numbers and epsilon. Where you send... Is that a vector maybe? Which is an x2. X with each lambda prime replaced with lambda. What if V is unambiguously defined? If unambiguously defined. What? X with each lambda prime. I still don't know. Okay. Xi lambda is an element of M, so it's like we just think of it as A. All for all S. Oh, okay. Oh, so this. Oh, the column means such that. Okay, such that. Whoops. Right. I do hope it was like written more in English rather than in mathematical notation, because it's like kind of hard to understand because it's too concise. All for all S in M. Okay. It's the smallest. What? It's the smallest element, kinda. It's the smallest element in M. I believe this M is supposed to be M lambda. M is supposed to be M lambda. A. Right, okay, let's look at this again. There exists... Okay, epsilon is in A. That's the first condition of A. And then, for all lambda of P1 to Pn, I still don't know what exactly they mean by P1 to Pn. For all lambda, for all expressions in lambda prime, then for all... Okay, then... Okay, it doesn't mean such that. For all lambda, and for all A1 to AN in A, lambda prime of A1 to AN is also in A. Lambda prime, can it just be any expression? What is it? What is it? Lambda K. Okay. Lambda have parameters, right? Lambda are symbols, mappings, and PKs are the parameters of the individual symbols. Lambda are... Okay. So Okay, what is lambda prime in like easy to understand language? I think so. Finite set of mappings. Maybe I just need to read more. Oh, what does it mean actually? What does this mean? Oh, I'll try to understand it. T lambda is a function from xi lambda 2 natural numbers starting from 0. So that if you put epsilon, it becomes 0. If you put an expression containing a1 to an. Wait, there's lambda prime again. What? Lambda prime is only a symbolic placeholder for later? Okay, lambda prime is a certain function. On the end of the section, there is a verbal explanation. You have to find a combination of the set of symbols listed inside of the angled brackets so that it evaluates to something fulfilling the equation. If you see a dot in a symbol, you can also put a combination of symbols there instead of just left and right. Instead of just left and right? Wait. You can also put a combination of symbols there instead of just left and right. When a delta is in the index of a variable, that implies that it can be exchanged to any natural number. The time is determined by the amount of symbols you needed. Xi lambda is basically the set of symbol strings you can make. If v each lambda prime replaced with lambda. So lambda lambda is the evaluation. So like what? Lambda small lambda is a function that actually calculates what? V delta equals 1. Lambda is just a symbol for example GCD and a dot. Lambda is just a symbol. Lambda is just a symbol. But big lambda is also just a symbol, isn't it? Big lambda is this expression. This expression is also big lambda. Big lambda is an expression and small lambda is also an expression? Here, this is supposed to be big lambda. Big lambda. Big lambda is the set of symbols available. Right. Huh. Okay. Okay. This is a time. Okay. So this is a time. This is a time. Why is it the time? Wait. It's not just counting the number Isn't it just n? Wait, it's not just n. I thought the number of variables you used is n, but I guess not. What is this? AI. You put it in the function again? Time is the amount of symbols you used. So it's not just what is T lambda of AI then? What is T lambda of AI? Where is that defined? Maybe it's Okay. It's recursive. Oh, so the lambda an expression can contain more expressions. And if it's a single, wait, epsilon stands for nothing. Okay, epsilon stands for just nothing. And every time you go into the recursion, you add one, so that adds one. Or okay. That with that explanation, I can understand what it means. With that explanation, I can understand what it means. And this is a level. Let them be arbitrary expressions. Then, if there exists an x such that, what is alpha here? Alpha of, okay, those are expressions. Wait. Set x beta equals gamma. If you put x, you should get x with each lambda prime replaced with lambda. Okay. Right. X. Wait, X. Wait, why is there an alpha before that? Anyway, this is a function. If you put x in there, if this exists, then you can just write this. And the solution for such a level, it took that time units, right? Okay. Right. Example. Let's look at an example from the actual clock. Inf arg min plus x. Basically the smallest argument of all global minima. For example, x squared plus x has only one minimum at that, and therefore this is plugging in x squared plus x to this small dot, right? Did we just plug x squared into this, or x squared plus x into this? Because it shouldn't make sense that way, right? Because wait. It can't be x squared. Wait, what? No. What's its thickness? What is up with that thickness? So it's this. We just plugged in x squared plus x here. What is this? That's the introduction to the symbol? What? For a set of two mathematical objects, it is usually the case that when they get written directly adjacent to each other, that the operation performed between the two is the standard multiplication in their corresponding field. With the symbols available. Wait. What symbols are even available? Oh. Oh. Wait. Okay, so the first... This is the expression we need to make, and these are the symbols available? Oh, all of these are symbols? Okay, all of these are symbols. You need to use all of these symbols. Wait, so... What is small lambda even? What is... I'm not... What is small lambda of delta? What is small lambda of delta even? Anyway, we are supposed to use these into... Like, okay. Okay. Right. Combination... Right, set of symbols listed inside of the angled brackets. Okay. I was so delved into this mathematical notation that I didn't even understand the English explanation. Right. Okay. So, combination of symbols there. Okay. And by the same principle. So, okay, when this dot and this dot, this didn't just mean putting variables there. It just means putting any other expressions that are presented in the same angled bracket. I thought this was like a set of all x1y or x1x, and I was like a little bit confused because is it just xy? I was like confused about that. But turns out we can also put in stuff like +1 like times something. Any symbol here. Any symbol there. Okay. Inputting an epsilon is just removing the dot. Okay. By the same principle. Right. So brackets are like this. Bam. Okay. Optimization. We need something that results in negative 13/10? No, 13/10. Just 13/10. So this is how... And you multiply it by that. 48 symbols. 1 and then 3 times something. Okay. Partial results as coefficients of polynomials. Coefficients of polynomials. Right. Okay, now I understand. I think you should have just wrote this up front right here. Right here. And then this should be in like a appendix or something. Because I can understand I do understand everything now. A proof, an analogy of tassing. proof. Right. So this is proving what's the lower bound of the symbols? Or like bringing it down? Bringing the upper bound, I mean, just proving it. Okay. Okay. Link. Right. Just depth. How many depth? 20? Bum bum bum. Bum bum. 21, 19. One design choice in particular which I want to explain here. You may have wondered pretty early on why there are still usual numbers displayed and maybe why the equations are weirdly aligned in between them. These. Additionally, the solutions for each equation seem to incorporate 2026 as requested, however at first they might seem pretty randomly chosen. The two last questions can be answered simultaneously with one explanation. Whatever the individual symbol sequences have to represent to beat each level solve the equation is an amount of relatively well-approximated radians you can rotate from 12 o'clock to land on each individual half hour. When looking at the example highlighted above, right. Oh, right. So the right-hand side of the equation is the radians. First and partially second question for usual recipient, this may look simply like a nerdy or abstract clock display, while a person knowledgeable about the game behind it can certainly embrace their interest much more. So, wait. So, again... So none of these puzzles are actually like solving to 1 to 12, right? It's not that like the minimum number of expression you can use is going to be 1 to 12 or something, anything like that. It's the clock is incorporated in a way that the numbers on the right hand side, or maybe if you like calculate it like maybe 26 divided by 20, and this, maybe that's gonna be, these are all radians that lie in the respective angles like this. So that's how I understood it. Would that be correct? Bam. Okay. Right. All right. Finally, epilogue. Oh. In between the numbers. Nice. And... Huh. Huh. A30 took you more than 3 hours to find a solution. Just proof that a solution exists, not even finding it. Right? Okay. Okay. Amazing. Amazing. Actual clock. That's a thumbs up. Nice, nice. Okay. So, I guess I'm not gonna try to, like, solve it here. Because obviously it's really hard and out of my level. But I think it's gonna be really interesting as a long-term goal if any of these can be solved by me. After I learn some college math. Okay. Thank you very much, Meister. We are going to move on to Sputnik. Great speedrun. Great speedrun. Okay. Multiply the side length in 1 o'clock by root 2 and it should be fine, maybe. So this is a clock that I skipped last time because I was too tired. And I think we already did 1 o'clock. We figured out there was some kind of mistake in the number. A was the area of, I don't know, the hexagon or the entire 6-point star. So the area of a triangle, of the big triangle, is gonna be root 3 divided by 4 times 2 root 3 divided by 3, which is half? Maybe? And if you the area of the thing is, I don't know. I think it might be still wrong. I'm not sure. I think it, yeah. Even if you multiply it by root 2, I think it might be, I might be wrong. It depends on what you're asking. It depends on whether A is the area of the hexagon or area of the triangle or area of the entire 6-point star. It's gonna change according to what is being asked. Okay. Okay. The next one is, this one was supposed to be... Wait. So, either... I'm not sure which one connects to 2, but there are 4 squares. I guess these two are 2. This is 2, this is 2, this is 0, this is 6. And we're supposed to do, like, what lies outside of... Wait. So Sputnik has some hints here. The 4 squares are the 4 sets 2, 0, 2, 6, and you can use set theory notation as Boolean operators on them. Right. Right. So that means 2, you need to think of this as 0, 1 as a set. And for 6, you need to think of it as 0, 1, 2, 3, 4, 5. 0, this one is just an empty set. So this part is what? Maybe there's a big not symbol there. Not symbol? Would that be a not symbol? So maybe we're supposed to find everything that's empty. Which is... I mean, it's weird that these parts are colored because it's like outside 2 but inside 2. So it's it's just, yeah, it's just an empty set. So if we do a not of all of that, maybe we're gonna get to maybe it's something like this. So yeah, maybe it's just some set theory stuff. Okay. Anyway, I'll just look at the things we couldn't do last time. So this one is supposed to be a Feynman notation of sine, cosine, and tangent. So the sigma s stands for sine. So this is sine of pi over 2, which is going to be 1, times 6 times, this is sine of pi over 6, which is a half. So that's just 3. That's 3. And then I don't know what this is. Maybe it's a minus. And this is a 6 plus 4 equals 10. 10 is a 10 combination 2, which is going to be 45. And I believe it's 45. I don't know. It's an arrow that goes from 4 to 5, and that's why it's 45. 4 to 5 o'clock. And then we never really got why this is 6. I still don't really know. Maybe it's the shadow that this cube makes. And the shadow that the cube makes happens to be right triangle? That's impossible. At least a shape like that is impossible. So maybe this length is just supposed to be the diagonal of this one side of the square, or maybe the diagonal of the cube. If it's diagonal of the side, then it's 2 root 2. If it's diagonal of the cube, then it's 2 root 3. Area of the triangle is, yeah, I guess it's meant to be the diagonal of the cube, because in that case, if these two lengths are the same, then the area of the triangle is going to be 2 root 3 times 2 root 3 divided by 2, which is 6. So I think that's the intended solution. This one, did it change from the previous? Plus, minus, times, and divide. The logical operators should be treated as plus, minus, times, and divide. Wait, which ones are plus? Wait. I guess and would be times, and this is NAND, maybe minus. This is or, not of or, maybe minus. Yeah. Maybe divide plus minus. Okay. So what do we have then? 6 times 2 is 12. 2 divided by 2 is 1. This is 1 plus 2 is 3. 12 minus 1 is 11? Maybe I'm wrong. 12 divided by... No, it's correct because this is 4. 11 minus 4 is 7. So 7 is correct. I think we did this one. I think we did this one too. This one is tangent of pi divided by 3, which is root 3, because this is tau and that stands for tangent. This is sigma standing for sine. This is gamma, maybe standing for cosine. So this is gonna be square root of 3 over 2. This is gonna be just square root of, yeah, I think that's correct. So if we multiply all of that, we get 3/4, which goes all along with the outer section of the clock, because the outer section goes like 1/8, 1/4. I still don't know why this is 3/8 actually. C times, yeah. I still don't know why that is, but anyway, this was like 7/8, I believe. This was either 0 or 1. Both can be correct. let's look at the hints. The lines on the Roman numerals can be expressed with a number over a line over the original numeral, kind of like a fraction. Lines on the number over the line over the original numeral. What? 6 minus 2. Number, maybe it's saying it's this, but that's negative 1/3, and that's not gonna give us 3/8 if we calculate that. That's 20. That's definitely 20. Maybe let's just calculate it backwards. Calculate it backwards. Or do we even calculate this first? Maybe we calculate this first? Not sure. But if we calculate this first, then whatever this is 20, this is 100. So this times 2000 has to be 3/8. Which is also very weird. I don't know. I don't know why that would be true. So yeah, I guess I cannot solve this one. I cannot solve this one. And this one, apparently it goes like this. I think that was correct. Yeah. So B, R1, R2 for polynomial values. But what is R1 and R2? Maybe it's supposed to be B, X, Y? In that case... For polynomial value... Wait, what's a polynomial value? I'm not sure. I'm not sure what that is. B of R1 and R2. Polynomial values. Maybe it's a polynomial that goes through these coordinates. Bars were for over 10,000. Right, wait. In that case, that's gonna be 6 over 10,000 minus 2 over 10,000. So it's gonna be 1 over 25. That? Maybe? It still doesn't give us that though. Okay. Maybe it's supposed to be... No. It cannot be a polynomial because there are two of the same x's. Yeah, and that's impossible. Okay. Maybe it's a binomial... Maybe it's just a choose function. Maybe that's kind of a binomial thing. But, I don't know. 0... Is that 1? Is that 0 or 1? I'm not sure. 2. But that doesn't make much sense for me. I don't know what polynomial values mean. I don't know what B means here. And... hello, dear Roblox is cool. Okay, hi. This one is supposed to be from Nemeth Braille. Nemeth Braille. You can use Desmos to help with this one. Nemeth code. And last time I was stumped because it was not a normal Braille. It was not the Braille I knew. At least when I searched for it, it was different from... Wait, how do I do this? Maybe I do it like... Maybe I do that. Just do that. Oops. Let's just do... whatever. Like this. And... That's open, close. What? Open, line, close. So it's whatever this is over whatever this is, right? It's a fraction So okay, let's calculate what that is. That's a 2. This is a, what is that? It's a superscript. Okay, maybe it's a to the power of. That is a 0. Okay, and then what's a single dot? Single dot in the middle right. Baseline? What? So it's like 2 to 0 and then baseline, so it goes down below? Baseline. No, but it's different from a subscript. Oh, baseline just means return to the original position. Okay. Return to the original position. And then what is this? Top right, it's a plus. It's a plus. And that's a 2. What's that? That's another that, and that's 2. Okay. So we have this. That just returns it to baseline. Okay. Bam. Then what do we have below? 2. Plus. Is that that's a 6. So we have this, which is 5 divided by 8. And that, yep, that goes along with all the other numbers. Finally, did we do this one? Maybe? And this one, I think the number was wrong, so Sputnik, I think, yep. Yeah, nuclear radiation question is supposed to have 6 minus 2. I guess it goes, it goes like this. And then, yeah, I believe last time this was a beta radiation, and when that happens, like when the neutrons turn into I forgot what it is in English, but the 6 becomes a 10. You add 4. This is 4. You add 4 to the number of the thing. Yeah. So now this one is correct. I believe we solved this one last time, maybe. Yeah. So this clock is complete. Yep. Thank you, Sputnik, for submitting that clock. Okay. Let's have a sip of water. And let's move on to Sunho Lee. It's a square clock. It's a square clock. Now, let's try solving this. So, we are supposed to find the areas of the dark squares. And I believe all the angles are like multiples of 15 degrees. So, and all the squares are supposed to be, like the smallest squares are supposed to be unit squares. The area of this is 1. Area of the white square is supposed to be, the smallest square is supposed to be 1. So, this is square root of 2. So the area of this is 2. Then we have the smallest white square has area length 1. So this is 1. Now, every rotation is a multiple of 15 degrees. Here, it should be a multiple of 30 degrees. So how long is that? Let's do this. Bam. Bam. That's 60 degrees, which means this is half. And this, root 3 over 2, which means this light gray square, that's a half of 1 plus root 3. 2 of that is 1 plus root 3. Minus 1, so this is root 3. So this has area 3. Nice. Crazy Run says, any advice for not messing up complex number arithmetic? Trying to break up 1 divided by 1 plus x5? But I am just so slow with the calculations. Like, calculate this when x equals 2 or something? If you're talking about like integrate this or something, then I cannot do anything. I can't help you. That's just insanely hard. Anyway, that's just that's just hard. So, yeah. Oh right, Mr. Lint, neutrons decay into protons. Yep. I forgot the word proton. I only remembered the Korean word. Now, here we have 4 squares, so that's of course 4. Whoops. Here we have my root 5 construction. So this is 1. Oh, it's different from my root 5 construction, or is it? Wait, this is supposed to be 1, right? This is 1 over the golden ratio, which is gonna be root 5 minus 1 over 2, which means twice of that is root 5 minus 1, and this is also 1, so this is root 5 times root 5, which is 5. Bam. Next we move on to, this is the same construction we saw at 3 o'clock, but just rotated 45 degrees. So if this is 1, this is root 3, and because it's rotated 45 degrees, this is now root 3 times root 2, root 6. So this is 6. This is a very doable clock, but then we get to 7 o'clock. Which one is 1 actually? This is 1, right? This is another, that's the same thing. So we have, I think the align went a little bit wrong here because these dots are kind of not on the same place, but I believe it was supposed to be also, this was supposed to be root 6, I think. And if this is 1, and this is root 6, then this is like root 7. This is like root 7. But then, what do we do here? We bring this line here. What are we doing here? I think these rectangles, every rotation must be like in 60 degrees or something. So 30 degrees or 60 degrees. So these rectangles have to be, they should be 60 degree. Yeah, 60 degrees. Yeah. Equilateral triangles. Oh, right. It's not 60 degrees. It's just these. Okay, this is an equilateral triangle is what's happening here. So this is 1. This is also this is also 1. So this is like root 3 because of 60 degree stuff. And that gives us, this is root 6. And this is the same line as this, just rotated like that. So this is also 1, which gives us root 7. And that is a way, I think that is one way to rotate root 7 line that's not horizontal to something that's horizontal. Yep. And that's constructible in PowerPoint. So this has area 7. Here we have 2 to root 2. Square that, 8. That's 9 squares. Okay. For 10, we have, that's the construction for root 5. So this is going to be root 10. Up. That's 10. And finally, here we have, that's also a construction for root 5. So this is root 10. 1. This is root 11. But then I think we do the same, almost the same thing as before. This has length 1 because this is a circle. We bring that here, we bring that here. This is 1, this is also 1. But then if you extend this line all the way up to here, this has the same length as this. So this has to be root 10. This has to be root 11. So this has area 11. And finally, we have, this has to be root 3. That's the construction from 3 o'clock. That's 2 root 3. 2 root 3 squared is 12. And that solves the square clock. Here's a square fish. Thank you for submitting that clock. Okay, next one is by Simon Creepers. Simon C-Mech CSC Creeper SC. Wait. I believe they, yeah. No, Oops. Okay. I believe they have a... Wait. Oh, they gave me an email. Oh, okay, I was thinking about... They gave me a hint because I failed to solve their clock last time. I was remembering where I saw that hint. They sent it to me through email, I think. Yep. Okay. So... We're gonna be solving this for quite some time because it's very complicated. Let's see. I am gonna bring a sandwich. So I'm gonna eat while solving this clock. Hopefully that speeds up my brain. Okay. 시계 보면서 먹겠습니다. Okay. Let's change the title. Math, clocks, eating, sandwich. Math, clocks, and eating sandwich. Let's see. Mr. Lint, good night. I am supposed to solve this 5x5 grid first. And I will like make W of sine H1 plus cosine H1. Give me Wolfram. W of sine H1 plus cosine H1. Shouldn't that work? Doesn't work. Okay. That's, of course, E. Wait. Actually, if that's a Lambert W function, the answer is just 1 because E is 1 e to the 1. Right. Sine 1 plus cosine, that's 2. F3 squared. Fibonacci number, third Fibonacci number. Fibonacci sequence. Is it 1 or 2? No. 0, 1, 2, 3. Okay, it's 2. 2 squared is 4. It goes 1, 2, 4. And then I don't know what X minus is. This is 16 in Korean. Let's go here. So F3 to the power of F4 to the power of F5. Laser Cutting Studio, hello. Thank you. F3 is 2. 2 to the 3 times 5. 2 to the 15. Okay? This is 2 to the 2 to the 2 to the 2, which is 2 to the 16. Okay, I get that. They're all 2 to the some power. Biggest possible tile in the 2014 number? Game called... That's 2048. That's a game. Biggest possible tile in... Biggest possible tile in 2048. What's the largest tile possible? So it's 2 to the 17. Yep, I guess it's supposed to be 2 to the 17. 8 is IX minus I. That's a great call. That's a great call. Amazing. Thank you. Let's also just make them into 2 to the something form. Maybe. So we have 0 there, 1 there, 2, 3, 4. We have 15, 16, 17. And that gives me a suspicion that this is 18. 2 to the most popular adult age. Is that 18? Most popular adult age. What is it? I mean, most popular? I actually don't know how other countries' adult age works, but like maybe it's 18. Doesn't that specific game end with 2048 though? But doesn't it continue after that, after you see the you win message? It was published in 2014. Yeah, there's a keep going here. You see, there's a keep going. So I think the answer is 2017 because it's just so nice, right? This has to be 18, right? I'm not sure because like in other countries it could be like not 18 years old when that like adult the age when you become an adult could be like different because it's arbitrary and other countries have different like criteria. And most popular is also like weird because are we going by number of countries that have that number? Maybe it's 18 still. Maybe 18 makes sense. 6 minus 2 plus 0 maybe is 4. K from K is 2. That's a K factorial. What? Really? Okay. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. That gives us 32. So this is 2 to the 5. 2 to the 5. Right. Still makes sense. Still makes sense, even though we are going, it's not 19. Maybe we're going like, maybe we're going like this. Forbidden number minus 3. Okay, now it makes sense. Because that is 67 minus 3. So that's 64, which is 2 to the 6. Yep. That's just 2 to the 7. So this makes a lot of sense. 0, 1, 2, 3, 4, 5, 6, 7. Let's see if this is an 8. Maybe it's not an 8. 206. Google. What is this? G? Log. Maybe log of Google. Divided by 2. And I guess log here, even though it's LG, because usually when you write LG, at least in computer science, it means log with base 2, but I think here it means log of base 10. So Google is 10 to the 100, so that's going to be 100. Divided by 2 is 50. Add that to this is 256, which is 2 to the 8. So the pattern still works. The pattern still works. X comma Y is an element of 1 to infinity. What? An open... kind of weird because this is actually a point in 2D space, but I guess let's just remove the brackets and say X is between 1 and infinity, Y is also between 1 and infinity. What is this? X? Oh my gosh. X to the... Zoom in and out, you kind of see it. Okay, Y... Is that 2? Oh, no, it's Z. Where Z is 2 log Y3. That's log X2. So 2 log Y3, plug that in here. The Y gets cancelled out and you are left with 9. The X gets cancelled out and you are left with 2 to the 9. 2 to the 9. I'm gonna take a bite of a sandwich because I'm hungry. Okay, that sandwich. Nice sandwich. Right. Here it should be 10, I think. Let's just check if this is 19. D dx of x to the x when x is 8. What? So let's say y is equal to x to the x. We want to see what is dy dx. Okay? To do that, we log both sides and we get this. Okay? Let's differentiate this. So we have this in the left hand side, and in the right we have differentiation of a product, which is gonna give me log x plus 1 because x times 1 over x. Now, dy dx is equal to log x plus 1 times y. Remember, y is equal to x to the x. Right? Right. By the way, log right now, log means ln. Anyway, plug in 8 here, and we get ln 8 plus 1, write it like that, times 8 to the 8, which is 2 to the 24. And what do we divide it by? 32 times 3 ln 2 plus 1. 32 times 3 ln 2 plus 1. 3 ln 2 is ln 8, so this cancels out. 32 is 2 to the 5, so this becomes 2 to the 19. And that checks out. Okay. So now we just know what the pattern is. Let's just see if it works. This is 1000 plus 24, which is 2 to the 10. Year of Unix time something something. That Unix time integer 2. That's the limit integer. Year 2038 problem. The year 2038 problem, Epocalypse is a time computing problem that leaves some computer systems unable to represent times after this day in January 2038. Bam, 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 bam. Bam, right? So it's 2048. Anyway, it's 11. Nice. Nice 2 minus devil number. Let's try 69 squared minus 666 plus 1. That's 4096, and that is 2 to the 12. Number of weeks between that and that, 157 years. 157 times 365 plus something divided by 7. That's number of weeks. As around that, and we didn't account for a leap year or anything. So yeah, that checks out. It's 8,192. 13. What is this? Is it? What is this? Tau cosine tau x. Why is there a bracket here? I think this might be a mistake because this is a square bracket. It connects to here, but why is there a bracket here? I think that one is wrong, maybe. It's tau cosine tau x anyway, plus 4 x cubed dx. Tau cosine tau x from 0 to 4, that's just gonna be 0, I think. Yep. So it's just 4. It's just this. So it's 4 times 4 to the 4, which is, wait, which is 2 to the 2 times 2 to the, no, something went wrong there. Okay. What am I looking at? This has to be 0. And oh, it's 4x. Oh, it's 4. If the 4 is cubed as well. So it was actually there's an additional 4 to the 2 there. So it's actually this, which is 2 to the 14. And let's just go a little bit more faster. 19. This has to be 20. 1 0 4 8 5 7 6. If that's just 1,004,800,576 is 2 to the 20. Don't know why 6 is small, but that's 2 to the 20. 1 divided by 0 plus 2 root 2. What? 1 divided by 0 plus. What are we saying? Maybe this is supposed to be like this? No. What? Oh, what? It's not even 2 root 2. It's like, what? Isn't it just the square root of 2? Isn't it just like the square root of 2? I'm not sure. Plus infinity. Goes to plus infinity. Okay. Oh, I get it. So it's saying root 2, but tetrated to the infinity, so means this, I think, and that is equal to 2. So it's just 2 to the 21. So this is 21. This has to be 22. There's 10 to the 22 divided by something. If it's not 22, I would be surprised. Why is there ... Maybe this is supposed to be 5 to the 22, and as it ends in 625, so I know it's I think there's a big chance that it's a power of 5. So I think this is just 5 to the 22, and it's just, yeah. At this point, we just know it's 22. 4. Is it times? Is it a dot there? Is it a minus? 4. It looks like a dot. It can't be a plus. It has to be a dot. Maybe minus? 3 squared minus 1. So that is 8. 8 to the 5. So that is 2 to the 15. That, I guess it's 4 times 2 to the 15 divided by 9 plus 8 minus 7 minus 6. That's 4. 4. That's a triple factorial, which means 4 times 4 minus 3, which is just 1. And that's weird, because now this is not 2 to the 23. Oh, wait, I think there's a missing parenthesis, because, you know, this one connects to here, but I believe there has to be an additional parenthesis there that that closes this one. And then 5 is on top of that, maybe. Yeah. I think then it makes sense because this inner part becomes 4 times 8, which is 2 to the 5. That to the 5 is 2 to the 25. Divide that by 4, we get 2 to the 23. So I think parenthesis is missing there. So it's 2 to the 23. And this better be 22 to the 24. Okay. I think it's just Roman numerals and it is just 2 to the 24. Let's see. It has to end in CCXVI, so 216. Yep, it ends in 216. V with a bar has to be 5,000. VMM has to be 7,000. And then LXX has to be 70,000. And then DCC with a bar has to be 700,000. And then M with a V with 2 bars, that's 7 or 6. Yeah, 6 million. And then we have X, that's 10 million. So this is 24. And we solved the inner part of the clock. And now let me look at the hints again. 루트 2 하면 4가 될 수도 있지 않냐 라고 하셨는데 문제가 있습니다. 자, so there's a question in the chat saying, could this also be 4? Could this also be 4? Now imagine if this is 4, yep, then this also has to be 4, and this also has to be 4. And now that does make sense, right? Because like this, right? You know, if you plug in 4 here, then you also get 4 here. So it does make sense that 4 is a solution to root 2 to the x is equal to x. Like, this is correct. This statement is correct. 4 is a solution to root 2 to the x is equal to x. Right? 그러니까 예삐님의 말씀이 요건 맞긴 합니다. 루트 2의 x승이 x다. 에 해가 4. But the problem is, what this actually entails is like, when you look at a notation like 0.999 dot dot dot, what this means is this is actually a shortened version of something like this. What does this get closer to? 한마디로 이제 점점점이라는 게 나오면은 어떤 숫자의 나열을 생각해요. You need to think of a sequence of numbers. And it's asking, what does this sequence get closer to? 이 숫자가 점점 뭐에 가까워지냐라는 질문이라고 생각을 하셔야 됩니다. And what this asks is, what does root 2 to the root 2 to the root 2 to the root 2 dot 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 get closer to? Bam. That's the question. 이게 지금 이 표기법의 뜻이라고 생각하면 됩니다. This is the meaning of this notation. What does this number actually get closer to? So that can only be one answer. Because if you actually compute these numbers, it's going to get closer to one number. So let's look at it. Bam. Square root of 2 is, of course, 1.4 something. Right? Square root of 2 to the square root of 2 is 1.63 something. Okay? And then that again to the square root of 2. That's 1.76 something. And if you actually just line up all of these numbers, it gets closer and closer to 2 and not 4. Yep. So that is why the answer of this notation cannot be 4. It can only be 2. There's also something hidden here. Okay. What is this? That's something. Maybe not. Maybe it's just a string, but it looks... Yeah, but it looks suspicious. R6, 1.5 p.m. a.m. p.m. What does that mean? Problem is, Simone Creeper sent me a hint, but they didn't give me like any solutions to the stuff. They told me that it was encrypted. Yeah, let's solve this one first. 3042 squared plus 159.5. 1909530. So 1909530 is 1. And the second is, what's that minus that? 587453. 587453. Maybe we need to change it in binary. Is PM short for plus minus? Wait, AM is plus, PM is minus. That makes sense. That makes sense. AM is plus, PM is minus. So in the plus minus, so this has to be an AM, this has to be a PM. Whoops. Okay. Converting this into base 2, it's 25 digits. Wait. Wait. I think what I'm supposed to do is this. So 2 to the 0 up to 2 to the 24. If 2 to the 24 is on, we color the 24 cell. 24, 23, 22, 21. It's kind of hard to see because it's... Okay, I'll just zoom in on a really small... Okay, it goes from 1, 2, 3, 4, 5... 0, 1, 2, 3, 4. Maybe... 0, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then we're gonna color in 0, 1, 2. We color 2. And then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Everything from 8 to 12. Bam, 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 bam. And then 13, 14. 14? 15, 16, 17. 16, 17. 18, 19, 20, 21, 22, 23, 24. 21 and 24. And that gives us a 1. So that's how you solve it. That's the code. Okay. Okay. That makes a lot of sense. Nice. So AM plus gives us an AM, and minus gives us a PM. So because this takes a long time to actually color it, I'm gonna quickly like write a code, maybe. Let's just go onlinegdb.com. Let's just do Python again. I have a love-hate relationship with Python. N equals something. And then we're gonna do okay. So, it's too small. Okay. So that's a grid, right? And this is not like an efficient solution, but like it's only 25 cells, so whatever. Ba-da-bum. That's the result we're gonna be printing. For I in range 25, if n bit operation 1 to the left I times, then results of index maybe I true. I forgot whether index Python list index operator that. Does that return the position of a specific item in the list? Right, right. So that should be the result. Okay, 4. Now, call in range 5 for row in range 5. Print result of row times 5 plus call. And then ending must be nothing. Then after every row, we print a line, and that should do it. Let's check it with this number. 19095300. Run that. Whoops, I should have just done false instead of false and true. I should do, I don't know. Does it print out these characters? Wait. Okay. It should print. Okay, sometimes it doesn't work. I'll just do it here. It should be able to print out these characters. No, it suddenly doesn't work. Okay, I don't know why it's reversed. Oh, stupid. Bam. Okay, now we have a working program that prints out the shape of a certain integer. And we're gonna, like, I don't know, put it here. Okay. And let's move on. Continue with the... So, 587453. First of all, I'm gonna do that. 587453. Put that in here. 587453. Run that. It gives us 13. How's that? How's that? BMAA 9 point I. I is the 18th, 18 and 36. So, base 36. Can I calculate base 36? Base to convert from 36 BMAA 9.I. Please, please, please. No, no, no. BMAA. Please, 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 please. Oh, it works, it works. Okay, 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 okay. 19515537. Point 5. And then we have 17 BFG base 36. 2021020. 0.5. So we have 1951553.7 plus 2021020.5. That's the plus. We have 2153658. Show me that. Please, please. Yes, that's a 2. That's a 2. Now instead of plus, we do a minus. 1749 4517. Please. And the website is lagging, so maybe I'll... Okay, it's 14. Maybe I'll post it here and do it here instead. Simon.py. Bam. But unfortunately, this is smaller. It should be doable. This should work. Yep, it works. It's kind of harder to see though. Okay, if this site doesn't lag, I'm just gonna use this. Because I'm not gonna set up the font size right now. Anyway. T T5900. What is that? Okay, if anyone knows what that means, please tell me. T5900. I'm gonna have a bite of a sandwich. I don't know what T-min means. Let's see this one. Minus plus, so maybe we need to do minus first. Okay. Ba 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 ba. Bam. 1665 4984. Run that. That's a 4. Change it into a plus. Copy that. Copy that. Paste that. Run that. That should be 16. Yep. Should work for other things too. CD AAE base 16. 1349 4414. Can I just do this? Okay, I think that works. Bam. 5. Change that into minus. 124 1 725. Bam. 17. Now, I do not want to do it for all the hours. I will just believe that it works, because technically if you have a plus minus, if you have then for any two numbers, like if these two are the target numbers, then you can pick the mean of those numbers to be this one, and the difference from the mean to be this one, and then it always works. So I believe they have done that for all the hours. Should work here, should work there, should work there. E to the, oh my gosh, 888229 digit O of N. Oh, okay. Okay. Is it N or is it supposed to be pi? I'm not sure. Maybe it's supposed to be pi of O-N? O-N. Not sure what that means. Okay, what is this one though? What is this one? Huh. Okay, this one is interesting because it's a quadratic function. Let's just solve that using our bad friend, Wolfram. Not a good friend. A toxic friend. Okay. Please. So we have two solutions there. Let's plug them in. Da-da-da-da-da-da-da. Search base 64 decode. Okay. So that gives us 23 and then 11. Nice. Let's do base 64 for this one and skip the rest of the hours. Base 64 decode. Wow. Let's see. Okay. Now, if I make one mistake, it's gonna crumble, right? Is it even... Okay, is there a way to distinguish uppercase I and lowercase l? Let's see. Is there I'm not seeing any so is this an uppercase I or a lowercase l? This is, Master of Cubing says, this is vertical bar and vertical bar. Don't YouTube links use base 64? Yeah. Okay, I guess for every occurrence of this vertical bar, we have to have 2 options. Let's do uppercase I. CX7J207. Another I. U. TBRWSBBE M7J207LKC7 LMGB7CX7L. No truer words have been said. No more poetic words have been said. Is this an uppercase I or a lowercase l? T7L. That's an uppercase L. GWRHSG. QZRSLH SVADSIB 3SVADRP4 ZSGQ ZSSP ZT. That's a lot of Z's. Is that a J? That's a J. That's sad. That has to be a J. JTRSLH SGQZSIB3TJJQ equals decode. Okay. So now that I have an almost working decode, I'll just start changing all the I's into L's and see. No, that messed it up. Did I make a mistake there? SB70 SK7CX7J207. Okay, let's change this to an L. No, that broke it further, so this has to be an I. But so what went wrong here? Maybe this B is actually a 6. Actually, wait. Now I'm recognizing there are no 6s anywhere in this string, so every B could be a 6. That's okay. So that was a 6. That was a 6. Let's go. So after that, what do we have? So maybe this is a 6. Bam. Yep, that was a 6. That was a 6. Okay, there are 2 B's next to each other. Let's see if this one is a 6. No, that's not a 6. Let's see if this one is a 6. No, that's also not a 6. Let's see if they're both 6s. They were both 6s. Okay. Then what we have? That's about... I don't know. Well, around here, maybe? Maybe that's an L. Bam. No, that's an I. Where did it go wrong? Maybe it's this. Yeah, maybe that's a 6. Bam. Okay, that solved it. And then where's that? That plus minus. That's where could that be? G. Could this be a 9? Is there a world where this is a 9? I don't think so. Is there a world where this is a 0? I don't think so. Just as a... Okay, let's see. What happens if I change that into random stuff? that breaks after. Wait, so it has to be here. The bug has to be here. Where? Where though? Maybe that's a 9? No, that's before. So there's something wrong here. Something wrong here. WRHSGQ. It doesn't seem wrong to me. ZRSLH. And what else is that's there's something wrong there. Maybe this is a 6 too. Bam. That solved that part, I think. And then what? Okay. Okay. I can't see. Maybe this is a 6. Okay. Now I'm almost there. I think. Okay, this plus minus was actually correct. This plus minus was actually correct, and I don't know where this went wrong. S63 LH. Where is it even wrong? What if I change here? It's around here. The mistake has to be around here. I cannot see it though. So let's just imagine that this is the intended. Okay, maybe because they don't know. Maybe because they don't know Korean. This doesn't make sense. These characters are wrong, but maybe they didn't know it was wrong. Maybe that's a possibility. I think because I don't know what's wrong. What's wrong with this right now? It's maybe S. Oh, it's SUA. Maybe that's it. Maybe that's it. Right. Okay. Finally, we have what we have is the so I think there's a letter missing. This has to be here. That's 70. That's to make it 77. But I guess that's a typo, maybe. Plus minus 4774848. Okay. That has to be it. That has to be it. Let's try it here. And let's see if it works. Put it here. That is 10. And now we should get 22. We should get 22. Bam. And that is 22. Thank you. So I'll skip the rest of the hours. The minutes, I think, are also meant to go like that. So I'll just do one in this 60-minute mark. Let's see. How much is that? 2723654 divided by 0.142557. That's 1/7. So we just multiply it by 7. It's gonna be that, and I believe that should give us like 0 or 60. It gives us what? That's what it gives us. Okay. Is it infinity or something? What is this? What is it? 0, 0? Maybe it's 0, 0. Oh, maybe it's 0, 0, 0, 1 all the way up to 5, 9. I think that could be it. Right. Okay. I'll just do one more just to be sure. This has to be 02 then. 1978 plus I know times maybe this is a dot times 1,069,000. Am I reading that correctly? No, 10,000. I read it backwards. It's this. Yeah. Yeah, that should be it. Okay. So how much is that? How much is that? That is that. Okay. Let's see if it works. Hey, it is 02. Kind of weird looking because there are only 25 cells, but it is 02, I think. Yep, so that's how it works. 02 something something up to 59. If somebody has time, they can check if all of them are correct. Bam. Right. Thank you, Zimek Creeper SC. Simon Creeper SC for that clock. Bonus question. What is this clock's radius in millimeters? What? Radius in millimeters. But where can I find any... Where do I even find any, like, unit of measurement? Pixels? I don't know. I think there were two single brackets missing from the middle square, and but it is a great idea, and the questions are tedious, but it was like kind of rewarding. So I think it's a very good math clock. Thank you. But that's the end of Simon Creeper SC's clock. Maybe use the battery to reference the scale. Really? Okay. Battery. Okay, in the hint, they say this clock can only work with one Xi R6 or one Xi LR6 battery. Any other battery does not work. Why? Well, take a look at the Xi R6 battery and try to compare it with a normal R6 or LR6 battery. What does it look like? R6 is an AA battery? What is R6 AA battery? R6... So R6 and AA are the same thing? I guess? Yep. What's an LR6 battery? What is an LR6? It's alkaline AA battery. The same. That's the same. Measures that much in length. Almost 2 inches. Millimeters, about 50. 50, so that's 50. Okay, 50 millimeters. But then why... How is it different from a normal... I guess that's a hint that's saying AM and PM, right? Okay. The battery is also the only way to calculate the clock's dimensions. Despite my clock not being perfectly circular, take the first philosophy in construction, i.e. perfect tools, meaning assume it is. Okay, so this is 50 millimeters. How many pixels is that? Or... how am I even supposed to do? Maybe I'll just go to PowerPoint. Okay, it didn't Didn't copy because it's a WebP. Just go do that. Copy that. Paste it here. Bam. So you can just measure it like this, right? Kinda. Bam. How? That's with 1.82. And what's the diameter of the circle? It is 7.5. So 7.5, 1.82. 7.5, 1.82. And then it's 50 millimeters. So the diameter is this much. And what we do is take the radius, multiply it by power it times pi. No, we were asked the radius, not the area. Okay, not the area, the radius. Radius of the square is just that times pi. So let's try that. And that's 647 point something. Wait. Okay, I think... Okay, I don't know. Wait, it wasn't even a diameter. It was just radius in millimeters. Sorry, it's radius in millimeters. It has to be this. 103. 103 millimeters. That kind of makes sense because if this is 50 millimeters, then this clock, the radius seems to be about twice as long as that. So I don't know. Maybe it's... I don't know. Maybe they will tell me in the comments. So that was SZY Mon's clock. I'm gonna take another bite of the sandwich. In fact, I'm just gonna take a little bit of time, like take a little break to finish my sandwich. I pause the thing for now. And let's say, well, I'll look at the chat and just answer some questions while I eat the sandwich. Okay. Hi, I'm the guy who said hi earlier. I'm sorry, I actually don't remember. Hi.
오늘은 영어만 쓰시나요? 한국어 질문은 한국어로 답해드립니다. When will I release OSTs? I mean, I want to do it, but right now I don't have time to work on it. Sorry, I want to do it quickly, but I don't know like what kind of deals I have to make. Like what kind of deals are good for me? Like there's just so many stuff I don't know about. Business stuff. I don't know anything about that with those kind of things. Don't you get tired? Of course, but well, not on this stream. What is my highest math mark and when? Math mark as in while I was in school. While in high school, I mean, like, so I did get all correct on a test. So if we're talking about that, then maybe like the highest mark is 100. Maybe like there are times when I got all correct, but well, that doesn't really say much because it's not like I got all correct on. It doesn't tell about the difficulty of the test. Like, so I don't know. Also, college. I didn't study much college math. The only thing I really studied was like, you know, when you first go to college, they give you like a basic, like, overview on all the math you're gonna do, and that's kind of everyone takes the course. So that's I took that too, and then I took linear algebra. So those are the only math classes I took in university. Good luck with the rest of the clock side. Turning it a good night. Do you play Maple Story by chance? Not now. When I was young. Maple Story. When like Mush Mom was scary. at the time when like you couldn't I once tried to catch this when I was... Mush Mom had level 60 or something at the time. And I was like, how does a Maple Story character look like? I don't know. Just big eyes, like, big sword or something. Hair. Hair something. I was like level 17 or something. And then I tried to catch a Mush Mom and I died like, run back, hit 3 times, and then die. Like, that's what I did to catch a Mush Mom, and I was so proud of myself for catching it, for killing it. Yeah. Can fish go to collage? Fish collage. Fish collage. There. 리부트 서버 너무 옛날이라 리부트 없습니다. 너무 옛날이라. Okay. Wait. Who is next? The first room? Uh-huh. Right. Copy, paste, zoom. Too big. Okay. Let's start the clock again. Bam. The next one is the first room's clock. Reference. It's a pattern. It's patternified 2 times 0 or 2 times 6. But I'm not sure what a reference means, but obviously it's a 0 or 12. Reference to like my video, maybe. A reference. Across a hydrogen atom's ground state is called... Wait, that's a 2-letter word? Hydrogen atom's ground state. 3 is future tense for win. Future tense for win? There's a future tense for win? It's just will win, right? I will win. Past tense is won. I will have won. I will win. I would win. I have won. Done by a single person. Maybe it's solo. And maybe it's past tense and it's won. And it's maybe the 1s orbital. But you don't say a hydrogen atom state is in 1s. Maybe the ground state for an electron of the hydrogen atom has to be in 1s to 1s1. I mean 1s1. So maybe that's why, yeah, it solves to 1. Maybe. This 1 times 2 in base 6 is just 2, so this is 2. We have 3, 4, 5. So 2 phi minus 1. Phi is this. So this is going to be root 5. That is going to be 5. And then a plus 1 is 5. A is 4. A minus 1 is... This is a 5. 4, 3. Right triangle. Also, 3 is now denoted as a red square. Right? Or... wait. This doesn't... Oh... The area is 3. Okay, this is root 3. Because this is 1, and this is 2. So this is 3 still. This is 3 still. Half of 3... I mean... This is going to be root 6, right? So that is why the area of the green square is 6. Okay. Nice. Can you construct Worldle in Math Clocks, in PowerPoint, in Andromeda Galaxy? The smallest regular polygon that cannot be made with a straight edge and compass construction is a heptagon. To you. To me. Right. If this is 2, then the volume is 8. By Vin. Okay, thank you, Vin. We have 6 and 3 from previous puzzles, so 9. 14 divided by 2 equals 7. 4 times 8 equals 32. This is Wordle, but math. 5 times 1 equals 0, 5. So we know green is correct, so this has to be 5, this has to be times. Something, I think this could be a mistake, because here you see 1 is colored yellow, but here 1 is not colored yellow or green, so it's colored black, so I think that might be a mistake. Maybe it should be colored yellow. And we know that 4 is not in the solution. 8 is not in the solution, 2 is in the solution, as well as 0 and 1. And the only way that makes sense is 2, 1, 0, like that. So the answer, 5 times 2 is 10. Wait, root 5 plus 1 divided by 2 minus... No, phi is this. So 2 times that is root 5 plus 1, minus 1 is root 5, right? The silent raven. F of n is equal to arcsine. That's another, I already forgot, subfactorial. Derangements, subfactorial, that is 1. Arcsine of 1 is gonna be pi over 2. Because sine of pi over 2 is 1. Arcsine is the inverse of that. So we have pi over 2 minus 1 plus 2, 3. Wait. Really? Is that it? Maybe it's supposed to be 90, as in 90 degrees. And this part is 6 divided by 6, so this is 1. and this is 89. Now, Fibonacci sequence does give us 89 at the 11th position. It is here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th Fibonacci number is 89. So n has to be 11. And that solves the clock. Thank you. The first room by Vin. Vin, thank you for submitting that clock. Now let's get on to... Are we doing recently submitted clocks? Like today? I mean, I don't have time to go through all of them in detail, so maybe I'll just skim through them. Yep. Okay, let's look at Yamahe GD's clock. I believe the original post, they told me there are some mistakes, so they sent me an updated version. Which one is it? Okay. And comments? Sent another one about number 2 just now. Wait. Okay, let me check my email again, just in case there's something new. Copy image, paste it here. Bam. That's the... Yeah, that's the newest clock that Yamahe sent me. Now. So... Li2. I have studied this. Wait. There is... Where is it? Maybe I just search for it. Bam. And... okay. I don't need to go any further down because this one solves... This helps me solve this 12 o'clock, because if you look at this, it says if you plug in 1 here, Li2 of 1 plus Li2 of -1 is half of Li2 of 1 squared, which is still 1. And we plug in this, so pi squared divided by 6. That's another pi squared divided by 6. So we get Li2 -1 becomes, that's pi squared over 12 minus pi squared over 6. That becomes minus pi squared over 12. And then we know that k is 12. Bam. Okay. I'll take a bite of a sandwich again. Two. I guess that's just a... is there supposed to be a right angle? Then we can just solve. Whoa, that's not. Bam. What? (68/5). 68 over 5. 68 over 5 is what? 68 over 5 is 13.6. 원래식을 넣어봐요. 이 원래식 이게 지금. Okay. Anyway, it shows 1 here, so I guess that's the 1. Yeah. Well, okay, I don't know why it's 68 over 5, but let's go. First, let's move on. 6 minus 2. Wait, was this fixed? I believe. Okay, I think it's fixed. That's 2 divided by 2, and then this is larger. And then we have 9 minus 20 over 4, 5. That's 4. And then wait, which line is larger here? Is it this line or because the lines are almost the lines almost form a parallelogram here. Parallelogram of dividing lines. I guess maybe is this 2.2? What? Wait, is it 2? It does look like 2.2, but then what is this 0? The upper one is smaller. Okay. 2 point. Is it like 2 times 2 to the 0? Maybe. Then it's 2. And then we divide it by minus 2 plus 6, which is 4. And then we divide it by 2 times 4 minus 2, so that is also 4. And we have wait. Which is this line the largest? Because we have 1 over. This is 2. This is 2. 2 divided by 4, that's a half. Just like that. And then divided by 4 is 1/8. It's the bottom line. Bottom line is the largest. So it works like this, which is 2 divided by 4, which is half. I think. Sum of all blue lines. 2, 0, 2, 6, 10, root 5. This is 1, so this is 2. Sum of all blue lines. This is 2. This is not blue. I believe these are all halved every time, so 2 plus, and then skip 1. And then this, which results in 3. Converging length, focal length 20. Wait. Okay. Where's the... Oh, right, they have a solution. Okay. Because I couldn't make out what was written there. But essentially how it works is, so this is a lens. If you shine light through a lens, it like if you point a laser through a lens like this, it curves. If you point a lens through the center, then it doesn't curve. So it can I draw a line? It goes like this, right? If you point a lens through the center, it doesn't curve. If you point lens, then it curves. So the question is, when and where do they meet? Like how, what if you do this and this, where do they meet? And object distance 20 means this is 20. That's what object distance means here. Image distance is this. That's what image distance means, and I cannot make that out, but I believe it's like 10 or something. No, it's 5? Okay, so that's 5. Or not. Or, right. So the question is, what's the focal length? And that's the distance from here to here, where this line passes through the middle. And they satisfy a certain equation, which is that if you add the reverse of this to the reverse of this, then it should give the reverse of this. So if you calculate that, x becomes 4. I believe that's what happens. Yeah. I think that's what happens. So that's why it's 4. Okay, value of x and y are real. 2 phi root 5 plus 1. So one of them has to be 5, one of them has to be 1. X is larger than y, so value of x is 5. 2026 in, that's a base, what? Is that a base? Wait. Okay, I don't know what this is. The bottom number represents the base of the upper numbers. We have to do it from top to bottom. Oh, I thought we were doing it this way, but I guess we are doing it this way. Okay, so it's like this. Because, I believe normally it would be, if you don't have parentheses, it will be like this. But in this case, I think we're doing it like this. So, that's gonna be how much? $10.46. $10.46. And then you do it again. Maybe you rethink of this as a decimal again, and then do 8 again. Maybe. Maybe that's how this puzzle will work. Yeah. So it's technically not this in base 8, and so on. You put this in base 8, turn it back into base 10, and then turn it back into represent it as base 8. And think of it as base 10, and then represent it as base 8 again. So now it's 550. Let's do that again. Oops, 550. Now it's 360. Do it again. Now it's 240. Do it again. I think I can do it now. 128 plus 4, 132, I think. No. 160, I think. And then if I do it again, 150 maybe? I think? Wait. No. Completely wrong. Wait, maybe I am completely wrong. No, that was correct. 160. In base 8 is 112 though, but 112 again in base 8. What's that gonna be? Oops. What is that gonna be? 74. Interpret that as base 10 again and convert it. 74. Bam. And that gives us 60. Now we put 60 in base 7. That gives us 42. 42. Interpret it as base 10 and then put it in base 7 again. 30. 30 base 4. Now that's 12. 12 base 4 is 6. So the answer is 6. Next we have 9088 hypotenuse. This is 7. We know that this is 2. We know that this is 44. So whatever this is like 90 to 90 to 2. So this is 44 times 45. Right. 1 to 22. Maybe I'm wrong. I think. No, I am wrong. I am wrong. That's wrong. That's not it. Yeah, that's wrong. What I need to do is this instead. I need to do this instead. So this is 44. That's also 44. Bam. Bam. That doesn't matter. Let's do that. So that is gonna be 90 minus 44, which is 46. And minus. What do we need? Let's call this theta. We know that tangent theta is 44 over 46. What is tangent 2 theta? Bam, 2 theta. That's gonna be 1 minus 44 squared. 22, 23. Bam. And how much is that? Bam. 1012 divided by 45. So that gives us this is equal to 90 times this, which is 24. And then, as we all know, this is gonna be 2026. So that's a reverse puzzle. That's a nice reverse puzzle. Because I didn't know there's what? This has an integer length. Denominator of sine of 6 degrees, maybe? Not 6 radians. Sine 6 degrees. Okay, it's this, so the denominator is 8. Okay. And then we have is this R minus 2026? X? What is this? ET? T minus 2026? No, that's the previous one. Okay, solve for x. Okay, so it was t. Left-hand side, you need to, yep, do u equals t minus 2026. That gives you this, right? Integration by parts, right? So, yeah, it's u, e, u, right? And x to the e to the x times e to the x. Lambert W function, 72,000 and stuff. And that gives you almost 9. Right. Okay. Gamma function definition integral. I thought, like, I was confused about it too, but if it's t, then it's just integration by parts. Right. So it's almost 9. X is almost 9. A particle's final velocity when its initial velocity is 6 meters per squared and accelerates uniformly at 2 for 2 seconds. So that means every second your velocity gets, like, you add 2 to it. So for 2 seconds, you add 4 to it. So you add 4 to 6, you get 10. Sum of the squares of the first 13 digits of this divided by sum of the first 12 digits of this. Wait. Last time we actually found out this amazing significant figures calculator. And bam. That gives us, like, all the digits here, right? That's amazing. Sum of the squares of the first 13. That's up to here. Sum of the first 12 digits of 2025. Bam. And that's gonna be like what? 10, 12. Bam. And we add up the squares of all the things at the top. 8, 4, 6, 2, 8, 6, 7, 1, 2, 1. 1, 7, 8, 4, 4, 6, 2, 8, 6, 7, 1, 2, 1. 3, 4, 1. 3, 4, 1 divided by, add up all the 3, 2, 4, 1, 0, 1, 3, 1, 2, 7, 6, 9. That's 30. Wait, that's 39? Okay. Maybe I'm wrong because it's 8 point something. This does divide by 11. This just has to be 31. Maybe I mistyped something here. No, I didn't mistype anything there. That's 12 digits. And that is correct. That is 39. Okay. Let's see. I think there was a mistake because here, when you take the 10 to the power of this, you see this has 13 digits
of like error. How do you say it? 13 digits of error, like 13th digit. But then this, when you power it to the 10, then it becomes much more error prone. The error gets amplified. So now less than 13 digits are correct here, I think. Yep. Oh, by the way, I also missed one donation by Astronaut, who sent me 1,414. Thank you very much for the donation, Astronaut. Thank you. Yeah, I will finish the clock stream today with the help of all your donations. Thank you. Thank you. Thank you. Yeah. But I think that's the clock solved. I do want to see what 1 was about. What's the solution for 1? 1 o'clock. Bam. Oh, it's 2 times 20. Right. This is 2 times 20. Okay. So that's 40 plus 26, and then that should make sense, maybe. Yep. So X is 1. Right. Huh. I never seen people write point like this, that the time symbol like this. 2.20, 2 times 20. Right, so that's what it was about. And then that looks nice. Thank you, MCSZ101, for the donation. Do I have my music out anywhere? I'm sorry, I don't have it anywhere. I do have it on Bandcamp, part of it. I'm working on other streaming services, but I'm not, like, I'm trying to work on it, but it's hard, and I didn't have the time until now. But, yeah. You can find it out in Bandcamp for now. Anyway, that was Yamahe's clock. Thank you for submitting. And we're gonna move on to Yuzuki's clock. It is here. Bam, bam, bam. Oh, I need the black version. Copy that here. Zoom. And let's try this one. So sign. Oh, by the way, first of all, we have all the angles in radians for all the hours, and that very neat. Here, this is one identity. Here we have cosine. That's what? Wait, maybe the theta I'm supposed to put in is this, right? So that's this theta I'm putting in. So cosine squared of cosine pi over 3 is 1/2. Right? Yeah, that should be correct. Minus sine squared of pi over 3 has to be this. Yep, and that's minus half times minus 4 is 2. Okay, let's see, pi over 2, put that in here. Cosine becomes 0, so it's 3. Put this in here, cosine of 2 pi over 3. Now, it looks like this. 2 pi over 3 is gonna be negative 1/2. So that's half. So that's 4. Root 4 is 2, times 2 is 4. Put this in sine. This plus 5 over that is this is just gonna be pi over 2.
which is just 1. 2 times 5. This is going to be 6. 5 minus 1, which is 4 over 6. So this, and divided by 2. So that's going to be cosine pi over 3. And that's going to be a half. So this cancels out, and the only thing left is 5. Put pi in here. 0 to 2 pi. 2 sine 6x dx. Now, what does that look like from 0 to 2 pi? It basically looks like this. And this is gonna be 2. Well, it's good. It should go on like a little bit more than this, but like imagine this is like 2 pi. It should repeat more than this. I believe we can just do. We need to find out the area under these curves. We can just find out area under one curve and multiply it by 12. So we're gonna do from 0 to and it's like this. It goes like this. Da, 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 da. Bam. So this times 12 minus 2. This is equal to it's like this, which is cosine pi da 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 da. Bam. So 12 times 2/3 minus 2 is gonna be 6. Right? 3 final exams tomorrow, Goose. Oh, good luck. Wait, it's March and you have final exams? Oh, what? Cotangent, theta, cotangent. So this is gonna be... I actually don't know cotangent version, so let's just write it back. Write it... I'll do t for tangent and t prime for this one. So we have this, which is equal to... if we multiply everything by t times t prime, we get this. And this is equal to 1 over tangent of theta plus pi over 12. So when theta is that, what do we get? Tangent of 12 of 15 pi, right? Right. That's gonna be just tangent 4 pi's, which is just 1. So this is just 1. This is just 1. The answer is 7. Okay. Interesting equations there. 4 pi over 3. 4 pi over 3. Root 3 minus tan x cosine x plus half. There are a few ways to go about this. You can do it the we can do it the L'Hopital's way, and just maybe differentiate both the numerator and the denominator. And put in x equals 4 pi over 3. Then you will get for 4 pi over 3, this is just gonna be negative sine pi over 3, which is this. And for this one, you'll get 1 over cosine of this is just gonna be... What's this gonna be? It's gonna be -1/2 squared. So this is gonna be 4. So the answer is this times 4 divided by this, and this cancels out, and the answer is 8. 8. 3 pi over 2. Just put in sine 3 pi over 2. That's -1, so this turns into plus. If 3√3 tangent 3 pi divided by x is equal to x, then what is x? Tangent. So, because tangent, the graph of the tangent function looks weird, this is only gonna have one solution anyway. Just let's plug in 9 and see if it works. Tangent pi over 3 is equal to x divided by 3√3 is gonna be 3, and that is indeed true. So x has to be 9 because there is only gonna be one solution. Here we have add up all the... Okay, first of all, this is... It's this. 2. What? Cosine 2n of 11 over 6 pi. So this is actually just cosine pi over 6, which is this, right? That's an interesting equation. So interesting formula. We basically have this, and then plus 7. So how does that work? I think this is just gonna be that. So it's just 3. 7 plus 3 is 10. We have 2 remaining hours. Fx equals this. What is f prime? F prime is equal to 6 secant squared x plus 2 sine x plus 4. And then we plug in this theta. So cosine of this is gonna be that's the same thing as that. Yep. Cosine is gonna be this. Sine is gonna be -1/2. So let's plug that in here. This is 6 times this squared, but then inversed. So it's this plus 2 times this plus 4, which gives us 8 minus 1 plus 4 equals 11. Finally, we have 2 pi. Put that in here, 2 pi. This is -pi. Oh, I don't want to do this by hand. Let's use Wolfram Alpha. Actually, I can do this by hand, but I already started typing in Wolfram Alpha. So, unfortunately, bam, it is 5. By the way, let's draw that in Desmos too, just to have a more complete grasp on what's going on. What's that? Oops. Yep. So that's how the thing inside the absolute value looks like. And if we put that in the absolute value, it becomes like this. That's minus pi comma 0. That's 2 pi comma 0. So we are integrating from here to here. The area under that curve is 5. Somehow 5. Plus 7 is 12. And that concludes the clock made by Yuzuki. Thank you very much. Thank you very much for the submission. Bam. Okay. Another sandwich break. While you look at the next one. Okay. Doesn't look that hard. Doesn't look that hard. Let's see. 1 o'clock. 1 divided by 8. 10 divided by 8. Rounded to the nearest whole number. 10 is closer. 10 is close to 8, so that's gonna be 1. Solve this Ken and find x. So, okay, I don't know what Ken is, but I'm assuming these two cells must sum to 7. These two cells must sum to 5. And we can only put 1, 2, 3, 4 in each row, maybe. And column, like Sudoku. Subtract 2, 6. So this is a 1, 2, 3 triple. Yep, it has to be. 1, 2, 3. This has to be a 4, 3 pair, which means this is a 1. Now, this has to be a 6. So 1, 2, 3 again. 1 cannot be here, so it has to be around here. It has to be 1 and 3 here, so this has to be 2. These have to be 4 and 3. Bam, because they have to subtract to 1, difference of 1. Now, this is 1 and 3. This has to add up to 5, but cannot be 2 and 3, so it has to be 1 and 4. Which means this has to be 3. This is a 1. This is a 1 and 2. Which means this has to be a 3. And that solves x. X has to be 2. Yep. Also, I think it solves the entire grid. It's gonna be 4, 3 like that. 1, 4 there. And then 1 there and 2 there. That solves the entire grid. Anyway, that was 2. 3 cosine squared x plus sine squared x is just 1. EIX plus E minus IX squared divided by 4 plus sine squared. What? Wait. Okay, it's just an equation. It's solving this by using this substitution and that substitution and making it as cursed as possible, but the answer is just 3. All of them is just 3. 8 divided by 2 is 4. 9th prime, 2, 3, 5, 7, 11, 13, 17, 19, and 23. Plus first prime is 2, 25. Root that, 5. We have... Moving on. This is 2 to the 4 is 16. That's 4. That's 2. 4 divided by 2 is 2. Wait. That is 8. Yeah, that is 8. No, that is 4. That is 4. I think there was a mistake. Maybe? Okay, just remove one of the 2 to the zeros. And it's gonna be 8. Oh, right. ddx this. That's gonna be negative 1 over x squared. Plug this in here. Then it becomes negative 1 over I squared divided by 9. I squared is negative 1. So that, everything cancels out. It's 9. Temperature conversion. 522 50. 50 Fahrenheit equals what Celsius? Now, Fahrenheit, water freezes at negative 32 and boils at 212. Celsius, water freezes at 0, boils at 100. So what do you do if it's 50? First, you add 32 to this. Which so imagine 50 is somewhere around here. You add 32 to everything, which means now we start from 0 and end up in wait. Is it not negative 32? Is it just 32? I forgot. It's just 32. I have mistaken the plus and minus. Now we minus 32 from all of that. We get 18 here. So this 15 becomes 18. And now we divide everything by 1.8 to make 180 go to 100. Then 18 goes to 10. So 50 Fahrenheit is 10 degrees Celsius. The number of vowels in this sentence. E, U, E, O, O, E, I, E, E, E. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Novel by Amy McCulloch, which features the protagonist Olivia going to Antarctica, published on June 22nd, 2023. Amy McCulloch. Oh, did I type? Okay, Books? Goodreads? Maybe? Does it have a... Midnight, maybe? Olivia, Antarctic. Midnight. The answer is midnight. Bam. And that solves the clock by Zach, or is it Zach E? Zach He? Anyway, thank you for subbing this clock. Bam. Nice music transition. Right. "2026 is the year of the fire horse. Even though it's late, I hope everyone has a happy new year. If there are any errors in the problems, please let me know and I would greatly appreciate it." Let's look at that clock. Good night, Zach. So we have determinant of, that is 12. We have to the 0 to there, that is 1. Log, that's 1 half. That's 2026 to a half, and that goes out as 2, and then this gets removed, so that's a 2. Tan squared of 20 times half times 6. Maybe it's tan squared of 60, which is root 3 squared is 3. Average eigenvalues of the matrix. Now, average means you need to sum the eigenvalues and divide it by 2, because this is going to have 2 eigenvalues. And the sum of eigenvalues is equal to the trace of the matrix, which is the sum of the diagonal. So this is 8. Average means 8 divided by 2, which is going to give us 4. In the Collatz sequence, right, starting from 2026, argmin 2026 minus x. Okay, so this means find the minimum number in the Collatz. Find the number in the Collatz sequence that's closest to 2026. Collatz calculator. Collatz conjecture calculator. Start from 2026. Now we are going to find the number that is closest to 2026 in this sequence. The live split covers a bit, but that doesn't matter. There are no close numbers there. This looks really close. I don't think there's anything closer than that. Right, so the number that's closest to 2026 is 2051. So x is 2051. Right? 2051. And I think this is supposed to be... There's supposed to be an absolute value here. So 2051 minus 2026 is going to be 25. Root of that is 5. Bam. Right. 김하민님 채팅해 계시네요. 감사합니다. Okay, let's calculate this one. This is going to be 13 over 6. This is going to be 6 over 13. 0 doesn't matter. This is going to be, again, 13 over 6. And this is going to be 25 over 6. So this is going to be 6 over 25. So this is going to be 6. The maximum value of k, that the equation 20x. So it goes like this if I move the things a bit. Plus 6 minus k. It looks like this, right? So this should have infinitely many solutions. Now, what does this look like? The left part looks like this. It gets closer and closer to 0 as x gets to infinity, right? It also goes like this. Sine 2 pi x goes like this, something like that. And if we go out, if this continues, then this and this are gonna meet infinitely many times towards the positive infinity direction. So how should we make it so... Okay, so when does this not have infinitely many solutions? It is when this thing stays above 0, like this. If it stays above 0, it doesn't have infinitely many solutions. If it stays completely below 0, it doesn't have infinitely many solutions, even if you account for all the things going on around here. If it stays below 0, then it's not going to have infinitely many solutions. They're not going to meet at infinitely many points. So, what's the maximum value of k that this has infinitely many solutions? Well. So, if it has to stay below 0, so the thing is, if we plug x equals 0 here, then what does this become? It becomes
7 minus k, because sine of 0 is 1. This is 7 minus k. And the thing is, this has to be below 0 for the graph to not meet this graph infinitely many times. And if this is exactly 0, then it's still gonna meet with the graph infinitely many times towards the negative infinity side. It's gonna meet infinitely many times with this towards this direction. Which means if k is 7, then 7 minus 7 is 0. Infinitely many solutions. If k is larger than 7, finitely many solutions. So, if the maximum value of k that makes this have infinitely many solutions is 7. Bam. We have something weird going on here. X minus y, x plus y. So these are... They are to... Wait. System of linear equations. Not linear, but anyway, system of the equations. And let's say x minus y, x plus y, x minus y, x plus y. So, wait, how does this work? X minus y, x plus y. I think we should do it. We should look at it like this. So if we look at y plus 1013 as a single unit, I mean, let's just call it, I don't know, z. And let's say this is minus z, right? So x minus z plus x plus z, that's equal to 2026. Right. What does that tell us? I'm not familiar with these kinds of equations, but let's divide it into a few cases. If they are both like greater than 0, if this is positive, this is positive, then that just means 2x equals 2026 and x equals 1013. X equals 1013, and then this has to be positive, so z has to be less than 1013. Like that. And then second, if they are both negative, then that just means if they're both negative, then that means just x is minus 1013, and then okay. So like that's one possibility, and one can be negative, one can be positive, which means it's like this. It works like this. Okay, I think that's correct. I think that is correct. Z. Yeah. Wait, no. Wait. Yeah. No? Yeah. Okay, so this... What does this tell us? I'm not sure. I am not sure. Oh, maybe it's not about solving this stuff. Okay. Okay. Right. This is a rectangle. It's a graph of a rectangle. If we draw this graph, it looks like this. For x and z. This is 1013, minus 1013, 1013, minus 1013. But
this equation has y plus 1013 instead of z, which means this equation draws, I think this square, and then this equation draws this square, I think. So maybe they are opposites. Maybe I reversed them. But anyway, the end results of two of these graphs is going to look like the number 8. And that is why this is 8 o'clock. That is very cool. Hello, Jack Bush. Hello, Jack. 0.2026 repeating. 2026. So I know that this is gonna be 2026 over 9999, which means that dividing this is gonna cancel out. It's just gonna be 9999 over 1111, which is gonna be 9. For 10 o'clock, we have 10 here, 26 there, which means this is 24. The sum of all colored areas is that. Wait. Okay, let's look at the radius of the first circle. That's not a triangle. Okay. Bam. So we have R 10 26 R and what would R be? This is 24. Bam. This is R. This is R. So because this is 24 minus R, this also has to be 24 minus R, which means this has to be this minus this, so R plus 2, and then we have this is also equal to R plus 2, and then we solved it because we know this is R plus 2, this is also R, and we know that this is 10. So 2R plus 2 equals 10, which means R is equal to 4. Right? R... Bam. R is equal to 4. So the area of the first one is 16 pi. And now let's look at how big the second triangle is. Now notice this is 2R, so that's 8, which means this is 24 minus 8, which is 16. So comparing this big triangle with this second little smaller triangle, we have the ratio of the lengths of the first triangle and the second triangle be 24 to 16, which is 3 to 2. Length being 3 to 2 means the area is 9 to 4. And using the sum of geometric series thing, we know that the answer is gonna be this. Right? I think so. I think there's a missing pi, maybe. And these are supposed to be... we are supposed to... What? No, maybe... okay, I... What? Eh? Am I wrong? Oh. Why did I write 4? This was 16 pi. I am stupid. Okay. So the answer is 2 to the 4 times 3 to the 2 divided by 5. And a plus b, alpha plus beta plus gamma is 2 plus 3 plus 5 equals 10. Bam. When 2026 degrees is equal to b over a pi plus 2n pi, a and b are co-prime, express b minus a in base 12 and find its units digit. Okay. So 2n pi means 360. What's 2026 mod 360? It's 226. So we just think of 226 degrees. Now, that's gonna be this much of 2 pi. Now, we divide both of these by 2. 180. 113. So this is divided by 2, 90. So B is 113, A is 90. B minus A is 23. 23 in base 12 is 1A. No, 1B. Because it's 12 plus 11. Anyway, the units digit has to be 11. That's why it's 11 o'clock, and that solves the math clock by Kim Ha-min. Thank you very much. Thank you very much for submitting that clock. Bam. The next one is from Park Busong. And oh, I didn't advance the timer. Let's look at this one. Copy. Bam. Bam, bam. Bam, bam, bam. Mu is... Wait. Where are my notes? It's here. I found it. No. Let's recall what mu means. It means it's the Möbius and if it's, so let's prime factorize this. This becomes 2 times 1013. Now there are two distinct primes. 2026 is a product of two distinct primes. And what this function does is you need to calculate -1 to this number, 2, which just gives 1. So pretty easy. GCD of 2026, that is 2, greatest common denominator, 2 times 10, 2 times 2 times 10, 2 times 13. Primitive root of 2026. So primitive root, maybe I'm wrong. Aren't there like multiple primitive roots? No, there's only 3. Okay, I'm wrong. There's only one primitive root of 3. Wait. So what's the thing that gives multiple values? Primitive root only gives 1. There's something root. But anyway, that's 3. And this tau is, let's look at the notes. Let's look at my notes again. What does tau do? Actually, what does tau do? Oh, it's the number of divisors of 2026, which is 1, 2, 10, 13, 2026. 4 divisors. So the answer is 4. Next up, we have 2026 shown as points on a 2D plane. Hi, Jarvan. Denominator of a and b, y equals ax plus b. This is a linear regression of the 4 points. Is it called linear regression? I forgot. Minimum, yeah. So maybe we just do like, how do you do linear regression on Desmos? Yes, linear regression, Desmos. Leave. Whoa. Oh. Okay, oh, I forgot. You just do tilde and it works. Right. So we have 2026. And that's gonna give us... Okay. Oh, I did it the wrong way. I did it the wrong way. Okay. That gives M 1.4, B 0.4. A is this, B is this. Bam. Denominator of A and B, both 5. Bam, bam, bam. That is an XOR operation to XOR 0, XOR 2. That cancels out. You only are left with 6. 2 or 0 or 2 or 6. 2, 0, 2, 6. You just look at all this just absorbs everything. The answer is 6. Bit operations. Okay, what is this one? Wait, what is this one actually? Do we have anything here that'll help me? Double parenthesis symbol math. Bracket? No, maybe we'll... Okay. Operation? Double parenthesis operation in math. No. Number theory, maybe? How do I even search for something like this? Number theory double parenthesis operation. It's just keeps giving me brackets. Order operations, no. No, 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 no. I don't know. Where is it from? Could it be like from group theory or something? How does it not give... Maybe combinatorics? Okay. There's no way to search for what this means. There's just no way. How? How is there no way to search for this? Searching with quotes? Not number theory. Maybe quotes around double parenthesis. Okay, let's try that. No, I don't know what this is. Moving on. This is 64 root. That's 8. Okay, it seems like people are all complaining about ads. Okay, let's see if I can turn off ads. Okay. Go to that.
trace of this, we just add these two. The second Fibonacci number is 1. Sixth Fibonacci number is 8. 1, 1, 2, 3, 5, 8. So it is 9. F2, F0, F2, F6, 10. Bam. Okay. Is anybody seeing any more ads? Is anybody seeing any more ads right now? Oh, TR is trace. But ads, like, the reason I can make content is because of ads. That's how YouTube works, so... Well, 2026 to the power of 10. Let's use a significant figures calculator. What? Right. It starts with 1, 1. 1, 1. 11. And finally, determinant of this is 12. So that solves almost all clocks. I don't know how this... What this does. What is this? I don't know. I'm not sure. Multi-set coefficient. Thank you, AYSZ. N multi-choose K. Multi-choose? N plus K minus 1. Oh! Oh! Really? Okay. I believe in high school I learned it like this. It looks... In high school I learned it, which it looks like this. So this is equal to 2 plus 0 minus 1. 1 choose 0 times 7 choose 6. This is gonna be 1, this is gonna be 7. So that is why this is 7. Right. Okay. Thank you, thank you. And that solves the clock for real. Okay. That was sub 6 hours. Before the last 3. And now it's time to do the last 3. Okay. Let's have a bite of sandwich. Okay. Bam. Ah, another bite. The next clock is by Cyan Froggy. This clock is an Olympiad math clock and should therefore be solved without a calculator. No Wolfram Alpha for you this time, Zai. Okay, well, for solving a quadratic, I'll allow it. Not only should you give the answer, but also prove that your answer is correct. For example, with 1 o'clock, simply finding a solution is not enough. You must also prove that no other solutions exist. You should start with 1 o'clock instead of 12 o'clock, since 12 o'clock is the hardest problem of the clock, which is better suited as the final boss of the clock. 1 o'clock is a good introduction as it's one of the easiest problems. You should also try to solve the bonus problem, and once again, calculators are banned. For the bonus problem, which is this, what is the size of the regular dodecagon if the area of the great triangle is equal to 1? Try to solve this without a formula that instantly gives the area, and without using goniometric functions to properly simulate the Olympiad experience. Anything you memorize purely for this problem, or problems very, very similar to this, is not allowed either. Following these rules, there are some really cool solutions, so I'd recommend that you try to find one. Good luck solving all of these problems. Everything outside of 6 and 12 o'clock should definitely be doable. Try to not get outsmarted by someone who is still in high school. I think you can do it. Only look at solutions if I am not in chat once it's time for my clock and you can't solve it. If I am in chat, I can give hints. Just ask if you want one. If it's most fun when you manage to solve a problem yourself, hints do not take much away of that experience. Bah. This clock features 12 problems. Well, actually, it's 13 because of the bonus problem. Styled somewhat like Olympia-type problems of varying difficulty. All of them are made by me. Some problems, like 4 o'clock, are very doable if you know basic high school mathematics, whereas the hardest problem, 12 o'clock, gets close to an IMO 1 level problem. Most problems are of similar difficulty, only 6 o'clock and 12 o'clock are significantly more challenging. Also, if you look at the problems themselves, you might think 2026 isn't featured anywhere. However, if you try to solve the problems, 2026 will show up soon enough. There is a 2026 hidden in the solution of each problem, except for the bonus one. In order to get the pictures in high quality on PC, follow these 3 steps, right? That's solutions on pictures. Okay, I'm not looking at the solutions. This is the clock. But I did something else. You see, today I came prepared because for the past 2 days I've studied not these questions. I haven't tried solving them. But I have put them as I made them into a LaTeX document, which is here. And let's move that thing to the left. Move that thing to the left. And you see, this is a so to simulate a proper IMO experience, I'm gonna write the solutions, not proper, but anyway, close enough. I am gonna write everything out as an assignment, like I'm doing an assignment for a college math class. By the way, this is the first time I've ever learned how to use LaTeX. Yeah, this is the first time I've learned how to use LaTeX. And it was hard. Find the answer to each problem. Do not use a calculator. Prove that your answer is correct. So, here are the problems. And as I write left, there's gonna be the thing on the right is gonna automatically update. 6 hours in, we're solving IMO styled questions. Okay. Let's see. Question number 1. I didn't use LaTeX for the Tom Rocks Maths contest. That was just Google Docs. Number of positive integers n such that if 1 is equal to d1, dk is equal to n are its divisors, then that, if that n is smaller or equal to d3 squared and d3 minus d2 minus d1 is equal to 10. Okay, I'm not going to look at any hints. Because today is the day of redemption. Last time I failed miserably. As they students today they say it's going to be easier than Number Basher's clock. Let's see.
Okay. Bam. So let D2 equals P and D3 equals Q. I wrote that wrong. So we have 1 D2, D3, something, 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 DK. Okay, I'm gonna use both that and this to explain. We have n divisors of n being 1 p q something something n. And the thing is, n has to be less than or equal to q squared, right? D3 minus D2 minus D1, which is Q minus P minus 1 is equal to 10, 10. So that we know this. Okay. I think, for example, if we look at all the factors of 16, it's 1, 2, 4, 8, 16, right? And the thing is, this is the square root of 16, right? The square root of the number, if n, like the square root of n, if it's in here, has to lie in the middle of all of the factors. And look at this, n is less than or equal to q squared, which means that n, the square root of n is less than or equal to q, and the square root of n, if it's in here, has to lie here or here, which means n, there are not that many entries in this list. There can only be like 5 or 3 entries here. Let's write that down formally here. Okay. Okay. Right. So, since n Okay. Wait. How do I write it? How would I write it in a more concise way? How are you going to make the Indian flag? It requires ITF values. I mean, it's possible. Indian flag in PowerPoint is possible. Just know that it's possible for now. Until we, you can see how we made it in the Discord server, but I guess we don't have the full solution laid out in a nice presentation. You need to wait for part 3 for that. Okay.
Wait, I have a question. This explicitly has D3 and then less than and then ... then DK. Are we... Well, yeah, is the question implying that K is at least larger than 4? I mean, at least 4. Is it implying that K is at least 4? Can I use that assumption, or do I have to... There are at least 3 divisors, so D3 can be N, is what you are saying? D3 can be N? Okay. Bum. Okay, so we've got that. And let's see. Then both P and Q have to be prime. Yeah, I know I can exclude K is larger than 5. You don't have to give hints for that. You don't have to give hints. Only when I ask for hints. And Q minus P is equal to... P is... So P is 2 and Q is 10, 13. N equals 2026.
Uh... Bum bum. Huh. Wait. Well, I already explained. Why? Okay, I need to explain. Suppose PQ is less than N, then there is exactly one factor of N. There corresponds there is a factor xn set greater than square root of n. Thus n, the number of factors less than or equal to x and oops okay, less than like that. I think, wait, that's the number of factors less than root n is less than k over 2. Or equal to, I mean. Since n Elliott Q D3 squared five. Okay. We should do that first. We can do that.
Bam bam. Factors of n are 1 pq pq so p then can I add a bird space? What is it? Bird space. V space, was it? That's how I add the vertical space, I think. Right. Right. And however, there are no prime numbers p that satisfy this. And another V space, and let's do therefore n is 2026 has only there is only one possible value for n, namely 2026. That solves our number 1. Bam, 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 bam. Okay, let's move on to our number 2. Number of ways to divide the numbers 1, 2, something, something, 2025 into groups such that all numbers are in exactly one group and such that the sum of all numbers in one group is divisible by 2025 and is equal for all groups. Actually, new command, br, that. Okay. We need to divide numbers 1 through 2025 into groups such that all numbers are in exactly one group. Sum of all numbers in one group is divisible by 2025 and is equal for all groups. So if we add up all of these, so there in total there are the number, like the sum of everything is 2025 times 2026 divided by 2, so that. And that's a prime number. That's the sum of everything. We need to divide it such that one group, sum of all numbers in one group, every group must be divisible by 2025 as well. So, group, yeah. Okay. Okay, I know how to solve this one. Let's,
be the sum of all numbers in one group. Of all numbers from 1 to 2025 is let's n be the number of groups. Bam, 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 frac. Oops, oops. Why did I put 2 there? That's stupid. Okay. Why did I put a 2? Oh, bat. Okay, updated. N R and I should put positive there. Bam. Bam, bam, bam. If k equals 1 and n equals 1013, wait. Suppose k equals 1 and n equals 1013. I should do this first. Only way to divide the numbers into single group. There's only one. Where did the 1 go? BR. Suppose k equals 1 and n equals 1013. Form a group by itself. We need to form 10, 12 more groups. And there are 24 remaining numbers, which are all less than 2025. So every remaining group should contain at least 2 numbers. So every remaining group should contain exactly 2 numbers. BR. Only way to sum numbers from 1 to 20 divide into groups of 2 such that every group sums to 2025 is to divide it as like that. What's 2020? 10, 12, 10, 13. Thus, there are only two ways. There are two ways to divide the numbers. Okay, and that solves 2. I think. Okay, let's move on to the next page and see number. Next problem. Number of natural numbers n such that n is the largest natural number that cannot be written as a sum of non-negative multiples of 7, 8, and p. Something like 7 plus 0 plus 0 is fine, but something like 7 and minus 8 plus p is not. Non-negative multiples of 7, 8, and p. With p being prime, and such that the number of positive integers n with n minus 11 and that cannot be written as a sum. Number of positives n is exactly 4, where it's like that. Wait, so p is... Wait, we can choose p. Wait. Technically, like, if we can choose p, then there's no largest natural number, right? Maybe we're supposed to count number of primes p such that something, maybe. Maybe I think that makes more sense, because I think it's worded like we can choose p, like, whatever. But instead, we have to, like, choose one p and find n, choose another p and find n. So I think it's better to word it as number of primes p such that and stuff, maybe? Yeah. Okay. That's not it. Here. Okay. 7, 8, and p. Number of positive integers. What cannot be expressed as 7, 8, and p? Yeah, maybe it's better, because, like, if we can choose any p, then the answer has to be 1, right? Because n is the largest natural number that cannot be written as that. As for any p, in that case, the largest natural number, that can be only one largest natural number. So I think then that the answer becomes 1. 7, 8, p. 7, 8, p. 7, 8. Okay. Let's look at, I don't know, 7n plus 1 to 7n plus 6. Right. So after this, what happens? So we cannot make any of those, right? I get that. What happens after 22? 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Let's see. At some point, you should be able to... There should be a pattern, right? There should be a pattern. Or maybe after some point, everything is constructible. We have 24, 32. Let's add 15 plus 8, 23. 14 plus 8 is 22. 25. Okay, I think the pattern is this. And I think 27... It's a... Can you make 27? Can you make 27? No. No. Yeah, you cannot make that. Yeah. So after this point, everything will be constructible. 43, 44, 45, 46, 47, 48. 48 is 8 times 6. 8 times 5 plus 7. 8 times 4 plus 7. 8 times 3 plus... I mean, whatever. It does work. It works. So, the only numbers we cannot make are these 21 numbers. Now, what does this mean? Largest natural number, n. I don't know. Okay. Okay. Largest natural number that cannot be written as a multiple of a it should still be one of these. N minus 11. Where does that lie? 41 minus 11. Okay. Is exactly 4. It's also no equal signs. No equal signs. So 41 is just impossible. 34, between 34 and 23, there are exactly 4, so it's possible. Between 33 and 22, it's impossible. How about 27? Between 27 and 16? I mean, below this, everything is technically possible. Okay. Okay. Let's see. Between 27 and 16, we have this, that. So like, oh, I forgot 33. Whatever. Okay. Okay. So, there are a few ways for this to happen. Maybe I just plug in all the values of p, because it's not gonna be that much. There's not gonna be that many. I don't know. I don't know. How would I, like, I feel like the fastest way I can solve it right now is just doing everything by hand. So... as follows. I mean, surely it's still mathematical enough. This is still mathematical enough. And we just list everything. 1, 9, 17, 25, 33, 41. 1, 9, 17, Bam. Surely, like, I just proved it in Excalidraw.
Uh... Ba-bam. Okay. Let's say, what was the possible? Okay. That removes 34 and 41 from the list. 33. $33, 434, and 41 from the list. I don't have that much of a list while speaking English. Thank you, thank you. I am working on it still. I'm still working on it hard. Because I just have to... When I was in school, I didn't really learn how to do, like... I didn't really try to do the... What do I call it? American accents? But... So, I had a Korean accent, and I just wanted to speak, like, try American accents, and I started learning all the pronunciations of words again. Could you, Zaya logo construction sheet made in a PPT? Nice, nice. Anyway. How do I only consider primes that remove 33, 34, and 41 from the list? Okay. Let's see. Two, three, five. I mean, should I just try everything? If it's 2, it has to be, okay, it cannot be 31, cannot be 29.
31 doesn't remove. 29 doesn't remove. Uh... 23 doesn't remove, right? 29 plus 4, 19. What's 9? 19. 33 minus 19 is 14. 15. What's it? 22? Right. Wait. I should start with 31, 29. Fails to remove 33 from the list. P equals 19. Removes the 3 numbers by 34 equals 19 plus 7 plus 8, and 41 equals 19 plus 22, 7 plus 7 plus 8. In this case, additionally, 27 minus 19 is 8. And 26 is 19 plus 7. In this case, n is equal to 25. But there are 14, 7, 18. Between 14 and 25. Right? 17, 18, 20. Cannot be 19. Okay, let's try 17. 17 removes 25. Bam. It leaves 27. 17 plus 8. Yeah. No. 27. Between 16 and 27 is 4. Okay. Removes. Wait. What was it? 25, 33, 34, 41. 25 equals 17 plus 8. 33 equals 17 plus 16. 34 equals 70 plus 17 equals 17 plus 24. Okay. In this case, 27, and there are 4 numbers left in the list between 16 and 27. Yeah. So n equals 27 satisfies the condition. Namely, 18, 19. Where was it? 20, 26. 18, 19, 20, 26. Removes all of that. Uh, 13, 26. So bam, bam, bam. 25. Wow. 14. Okay. Uh, 20, da, 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 da. Okay. In this case, so let's add all the line breaks. And 25. So n equals 25 satisfies the condition. Unless I made a mistake. I think it makes sense. Okay. Next up is 11. 22, 33. $29. What doesn't work? Wait. Right. It's not 14. I put 11 somehow. Do I really have to solve it like this? Okay. P cannot be 13. Okay. Ah! 11, 18. uh, 19, 26. 33 by adding 7s to 1, 8, then 7s, and removes 27, 34, 41 by adding 2 8s, then 7s. And 7s. And 20. Between 20 and 9. In this case, n is 20. And there are 4 numbers left in the list between 9 and 20. Namely, 10, 12, 13, 17. So, n equals 20 satisfies the condition. Okay, and now we need to do p equals 7. No, I'm stupid. Not p equals 5. P equals 5. Remove all of that, 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 all of that. And what are we left with? 11. Uh-huh. Okay. In this case, n equals 11. And there are more than 4 numbers in the left in the list between 0 and 11. P equals 3. Please stop saying okay. Okay. Finally. Wait, finally let's do p equals 2. Only leaves. What does that do to this list? Well, it removes all of that. And it removes all of that, that, and that. It only leaves 1, 3, and 5. Therefore, the possible values of n are 34, 27, 20, So the answer is 3. That was 3 o'clock. And now let's look at 4 o'clock. Number of integers n such that there exist primes p and q with pq equals this. PQ. Wait, the first one is divisible by 2. Right. At least 3 prime factors if is a composite number. Therefore, therefore, either that or that. Suppose n squared minus 23. Oh, I forgot an n there. N squared minus 23n plus 23 equals 1. Then n minus 2 n minus 1 and minus 22. Satisfy the condition. Suppose n squared minus 23n plus 23 equals negative 1. Then 24 .
I believe. Yeah. If n is equals 0, then PQ equals 46. I mean, satisfies the, I mean, I should have just done n is minus 1. N equals 0 or n equals minus 1. In both cases, n squared minus 23n plus 23 both satisfy the condition. Yar. Suppose 2n squared plus 2n plus 1 equals negative 1. Then n squared plus not an integer. Therefore, the possible values of n are 1, 22, 0, and negative 1. Thus, the answer is 4. And that solves question number 4. Please update right. Question number 5. Number of positive integers n such that there exists a triangle ABC with ACB is 90, AB is n. ACB... AB is n. Such that D, AD, BD, and CD are all integers. CD is 45. And that the area of triangle BDC divided by that of triangle ADC is an integer greater than 1. Right. This should be it. Area of triangle BDC area of triangle ADC divided integer greater than 1. Okay. I don't know what theorem I should mention, but it should be it's just common knowledge, right? Let AD and BD
CD squared. So xy equals 20, 25. BDC area of triangle ADC is this. This the area of triangle BDC divided by that of triangle. No, thus y divided by x is an integer greater than 1. Since 2025 is equal to, let's just write it as 45 squared. Since 45 squared is equal to 9 times 5, 3, 4, 5, 2. All possible values of x, y are as follows. And I'll just list them and end the problem, which is 1, and y equals 3 to the c, 5 to the d. It should be that a LAQ, D, and X, Y. Bum 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 bum. Right. Five. I guess I'll just do that. And that makes sense. I forgot the 1 here. And that's it. The answer is 5. Da-da-da-da. Hour 6. Where's the 2026? Well, here it was in the value of PQ, and here it was... It's just 2020... It's the 2025, like... 145 2025. Yeah. Two to the 169 minus. Wait. Is this log 2 169? Is this maybe? I don't know. I didn't know of this method of writing logs. So it's supposed to be log 2 to the 169 maybe. X, where X is the number of ways to put the maximum number of bishops on a 10-14-10-14 chessboard such that no two bishops are on the same diagonal. 10-14-10-14 bishops on a chessboard such that no two bishops are on the same diagonal. Dun, 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 dun. The white squares only look at white squares, and the black squares only look at black squares. Half of the board is white, half of the board is black. I think maybe I'll just look at white squares, and then multiply that by itself to, that to the power of 2 to get the number of ways for white squares and black squares. So I can't put anything there. I can't. I should rotate my head 45 degrees. Rotating my head 45 degrees. This sees all of that. How many can there be? There's one. How many diagonals are there? White. 1, 2, 3, 4, 5, 6, 7. 7 vertical diagonals. There can be at most 7, but wait, horizontal diagonals. 1, 2, 3, 4, 5, 6, 7, 8. 8. But like, yeah, you cannot place 8 because there are the vertical diagonals. There are 7 vertical diagonals, and you can only place 1 in each vertical diagonal. So the maximum is 7. How do you actually get 7? Is it better to put it in the corner or here? This is just better than anything here, right? Actually, wait, 8. I'm calling this horizontal. 8 horizontal lines, 7 vertical lines. Can I even put all 7? 1, 2, 3. 1, 2, 3, 4. 1. this sees all this diagonal. This sees all that diagonal, all that diagonal, all that diagonal, and we have this left. And we have this left. So we can put it here. Wait, why is it white? That does give 7, I think. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that's the solution. This one. How was the answer? It should be like a 2 to the power of something. Okay, 2 to the power of something. This one can go here or here. Is that the only way? Yeah. They can only go here or here. Because there are 8 horizontal diagonals, but 7 vertical diagonals, so you can only waste 1 diagonal, waste 1 of the 2 diagonals in the end. So you can only put it here or here. And then this is there should be 1. These 2 should contain at least 1 because it's in a diagonal. And you can place it anywhere, but the other thing has to move too. So it's either this or this. And then these 2 are connected, so it's either this. It's either this or this. And these 2 are also connected. It's either that or that. So it's 2 to the power of 1, 2, 3, 4. I think I solved it. First, what was it? We just for even whites and blacks. 1014 is even. So the formation of white squares and black squares are the same. We will only consider the white squares from now. The white squares of the board as follows. I think I want to draw something here. I think I want to draw, let's say, something that looks like this. And add a ... How many were there for 8x8? It went up to 1, 2, 3, 4, 5, 6, 7. Bam. 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 And bam. Let's put this thing. Bam. Master of PowerPoint at work here. Bam. Let's do Iguana Tech. Iguana Tech. What was it? Wait, so 1014 by 1014. 1013. Bam. Okay. We have a trick here that's gonna make this look cooler. Have it be 3 points wide. Have the shape outline be white, and then place this on top. That creates a nice over something effect. Even larger. Okay. Look at how it looks like the line is going through all the vertical lines. Yeah. Bam. So we save that as a picture. I'm saving it right now. Okay, I saved it. Bam. And we put that in here. I forgot how to put an image. Okay, that's how I do it. Bam, include graphics. Put that in there. That's a big one. 5 centimeters should be enough. Right. Put this in a new page. Bam. Nice. Note that there are vertical rows, but 1014 horizontal rows. By 45 degrees, and picture it as follows. Picture it is not a mathematical word, but anyway. There cannot be more than 1013 bishops. However, it is, and it is possible to place the bishops with the following algorithm. Is algorithm the right word? Following method, I guess. Method. I shouldn't call it vertical rows. Column. The first row and the last row consists of only one cell, one square each. Since there are rows, we cannot waste both rows if we were to place 1013 bishops. Therefore, exactly one of the two squares must be occupied. Next, the second row and the second last row, with the middle column removed, the second row and the second last row only has two squares left. To place, there are only two ways to place bishops in these two rows, namely, top right and bottom left, and top left and bottom right. Continuing this fashion, for after placing all, continuing in this fashion, after placing all bishops in rows 1, 2, n, and how many rows are there? For 1,000 rows. The rows n plus 1 and 114 minus n will only have two squares left. There are only two ways to place bishops in these two rows. Namely, I don't need to write that. After continuing complete, this method guarantees to place 113 bishops on the squares and encompasses all possible configurations of 1013 bishops. Therefore, the number of ways to place bishops on white squares of a 114 by 114 times 114 chessboard is 2 to the What is it? 507. Because in each step, there are two choices to make. Two options to choose from. I mean, options to choose from. Since the white squares and black squares are independent of each other, I wrote it x, so x equals 2 507 squared equals 2 to the 1014. Thus the answer is log 2 to the 169 and 2 to the 1014 equals frac 1014 divided by 169 is equal to 6. Oh, right. New page. Seven. Number of triangles ABC such that ABC 90. Number of triangles ABC such that 90 degrees. See, this is B. AB and AC are positive integer B. That's C. That's A. Positive integers. Right. Okay. Let A be A and AC equal C. Then positive integers A and C should satisfy A squared plus 90 squared equals C squared. Okay. I should take a bite of a sandwich. What is this even? What's this? What do the Pythagorean triples satisfy? I actually don't know. AB and AC. BC equals 19. Okay. By Guatemalaki. By two m squared minus 1 m squared plus 1. Okay. Okay, can I even use that? Is it okay to use that? Well. Well, how do I even start this if I don't know about Pythagorean triplets? So we should do, suppose suppose 90 divides A and C, then I mean some integers. Maybe. I feel like this is how I should do it. Maybe it's wrong. maybe 3. Wait, why do I have to put 3? 3. No. No, there are. No. Wait. I don't know how to do this. I just don't know how to do this. Because I don't know anything about Pythagorean triples. Okay, let's say... Therefore, maybe I do this. 90 squared is 45 times 2 squared. 2 to the 2 times... 5 to the 2 times 3 to the 4 is equal to c plus a, c minus a. Maybe that's it. Okay, I think this is it. Okay, this is it. This is it. Since a and c are integers, c plus a and c minus a have to be both odd or both even. Since they cannot be both odd, they both have to be even. Let c plus a equals 2k and c minus a equals 2m. Then and k times m. Bam. Options to this are the all values of km are listed below. Let's write down all of them. Bam. Bam. We got that. We have this. We have this. And then
Bam. Wait. Didn't mean to do that. I meant to do... Wait. What was I trying to do? I think I was trying to do this. Right. So that's all the 3 to the 4th, all the 3 to the 3, all the 3 to the 2, all the 3 to the 1, and no 3 to the 0. Yep, so that's all. Thus, the answer is 7. Now let's move on to our number 8. Minimum number of non-doubling steps required to reach 8105 if you start with 1 and can only double or add 1 to a number. A non-doubling step is to add 1. This is binary. This is binary. Because if you 8105 in binary. How do I write that? Observe that whenever double a number, number of ones in the binary representation of n and 2n is the same for all positive integers n. Part of 8192 minus 87. $87 is 64 plus 13 which is going to give us subtract minus 1 minus that minus that minus that. That should be it. That should be it. I think that should be correct. in the binary representation of at most one more than the number of ones in the binary representation of n. At least 10 non-doubling steps. It's possible to show that create 8105. The binary is wrong? Okay. Okay, I'll do it again. Oh, it's 23. Okay. I'm just stupid. I'm just stupid. I'm a fish. I'm a fish. I can't even compute binary. Okay. 87 minus 64. I can't even do that. It's 23. It's 23. So 4, 5, 6, 7, 8, 9. 9. By it keep nine, 8, starting from 1, with 8 non-doubling steps. Whenever the and that solves it. Thus, the answer is 8. Right. Okay. Wow. Okay, 9 o'clock. 9 o'clock. Number of 4-digit numbers n a, b, c, d such that the number formed by the first 2 digits 40 is equal to that and such that the number formed by the first 2 digits is 10a plus b. Thus, we have 10a plus b equals c a plus b plus c plus d. Um, let's a equals 1. Then no, maybe I just have to let C equal 1 and stuff. D is less than 10, so A equals 1. Nah. Okay. Let B equal 2k. Then 4a minus k minus 2 equals D. Has to be less than A plus B plus C, so it is a contradiction. If A is 2, possible. So the possible values of well, okay. Divide it further. Divide it further. If a is 2, then 6 minus k equals d. Then d is 6. 4. 4. And 4 plus 2k. D. Put 6 minus k there. Is that true? If a equals 2, then 6 minus k equals d. Since 4 plus 2k is less than or equal to d, we have 3k is less than or equal to 2, so k is equal to 0. If a equals 3, then um 2 plus a plus 2k LQD. No. Then, what do we have here? What do we have? What do we actually have here? 12 minus 10 minus k equals d. Since 5 plus 2k LEQD, we have 3k LEQ 5. So k 0 or k is 1. This results in 2 cases. If a equals 2, then since 4 plus 2k less than or equal to d, we have that. 3k is less than 5 if a equals 4, then oh right. And since d
No, I didn't say it would only take 5 hours. I said I hope it takes 5 hours because I have things to do today. And I just have to postpone all the things I have to do today. If A is 4, 16 minus 14 minus K equals D. Since wow. Six plus 2k is less than or equal to D. We have I am just the stupidest fish alive. Or 14. Oh, wait. Right. Inequalities. If A is greater than or equal to 4, then 4A minus K minus 2 is greater than or equal to 14 minus K. Since 6 plus 2k, not 6 plus 2k, it has to be A plus 2 plus 2k, LEQD. We have... Wait, actually that doesn't help me, does it? 6 plus 2k plus... Wait, that doesn't help me. Wait, how do I do... Wait, I cannot do all of... I don't know how to do all of them together. Wait. Wait, so if A is greater than or equal to 4, then from here we have 4A minus K minus 2 is D. D is greater than or equal to 14 minus K.
since D is less than 10, we have K larger than 4. And then, what's this other thing? Right. That's how we do it. Alright. Oh, that was so painful. I don't know why it took so long for me to understand that. And the problem is it's not over yet. There's a lot more to do now. I don't know why it takes so long for me to think about that. Okay, let's C equals 3. Then 10a plus b equals 3a plus 3b plus 9 plus 3d. So 7a minus 2b minus 9 equals 3d equals 9 plus 3d. A plus b equals... Okay, is there anything wrong? 10a plus b equals 3a plus 3b plus 9 plus 3d. That's c times a plus b plus c plus d. 3393. Yes, 10 minus 3 is 7. b minus 3b is minus 2b. 9 plus 3d. True. 7a minus 2b has to be multiple of 3. Do I start with that? This has to be larger than 9 plus 9. Therefore, a has to be at least 3. If a equals 3, then... if a equals 3, then... Oh, I have to choose c equals 0 too? Okay. Let's c equals 0, then 10a plus b equals 0. So, a contradiction. Back to a equals 3. If a equals 3, then 30 plus b equals... No. 7a, 21 minus 2b equals 9. 12 minus 2b equals 3d. B has to be a multiple of 3, so let b equals 3k. Then 4 minus 6k equals D. No, 4 minus 2k equals D. However, LEQ 4. Since D LEQ 4, we have K equals 0 and D equals 4. No, this is, no, I should have said, it's a contradiction here, because D has to be larger than 6, larger than or equal to 6, and 4, a contradiction. And I think we can do a if A, I did A equals 3 independently for no reason. Okay, I'm stupid. I should have seen that. I should have seen that it works for GEQ. If A is larger than or equal to 3, then right. Now, everything I do it because I'm stupid, okay? Everything I do, it's because I'm stupid. 12 minus 2b equals 3d. I need to change that into 7a minus 9 minus 2b equals 3d. That's gonna be GEQ. No, LEQ 12 minus 2b equals LEQ equals, right. B has to be a multiple of 3. No. This part doesn't matter. And remove that. It's easier to sketch or plan before trying to type in the... Okay, yeah, that was the stupid part. I should have sketched it and... But how do I sketch it? Maybe... I'm just not fit for this, right? I need to refresh. Okay. Whew. Let's go. Let's go again. Just right. What was I missing? I was going for A equals 3 here, a C equals 3 here. But what happens if C is larger than or equal to 4? What happens if C is greater than or equal to 4? CA plus CB plus C squared plus CD. That's greater than or equal to 4A plus
4b plus 16 plus 4d. And this has to be equal to 10a plus b. So 6a minus 3b greater than or equal to 16 plus 4d. 6a minus 3b greater than or equal to 16 plus 4d. 6 plus 4d. And what is it? D is larger than or equal to a plus b plus c. What if I just put it here? Maybe that's it. Maybe that's how I do it. And that's larger than or equal to 32 plus 4a plus 4b. And if I move it this way, then that gives us 2a minus 7b greater than or equal to 32, which is impossible. Right. Wow. Oh, it was so easy, and I was just lost for 30 minutes. It was so easy. I just wasted 30 minutes down the drain. Okay, so let's say just CGEQ3 and check it out, check if that works. I'm about to cry. Oh, let C greater than or equal to 3. Then 10a plus b is greater than or equal to 3a plus 3b plus 9 plus 3d. Since d is greater than or equal to a plus b plus 3, we have 10a plus b is greater than or equal to 3a plus 3b plus 9 plus 6a plus 6b plus 18. Wait. No. No, that doesn't work. So it only works for C greater than or equal to 4. Is that? Back here. If A is greater than or equal to 3, then D, 6, A plus 3, and... Is that true? Where did I even get that from? D. Yes. That's just... No. No. And 12 minus 2b. We did that. Uh, 7a minus 9 minus 2b. That's greater than 12 minus 2, right? Right. Is 3D.
3a plus 9. What am I missing here? Oh, right. Here. If a is greater than or equal to 3, then three a plus 9. I think I am an idiot because I don't know how to solve this again. My brain just reset, I think. I think my brain just reset. Did a factory reset. If C is 3 and A is greater than or equal to 3. A greater than or equal to 3. A, 10A plus B is equal to 3A plus 3B plus 9 plus 3D. But D is greater than or equal to A plus B plus C, which is 3. If A is greater than or equal to 3, what does that do for me? This is 7A. Maybe I just do it like this. And that's greater than or equal to 21. What is happening here? What is happening here? 7a equals 2b plus 9 plus 3d. I don't know. I remember that Cyan Master said I need to do a equals 3 and a I can do this in one go. I have to do this in one go. I should be able to do this in one go. Maybe I just move all that again. Do 7a minus 2b minus 9 is 3d, which is greater than or equal to 3a plus 3b plus 9. And I get 4a minus 5b greater than or equal to 18. But where does that bring me to? Wait, made a mistake again. I made a mistake again. GQ, that's a GEQ. So it's a GEQ. Okay, I think now it's correct. I think now it's correct. People are leaving the stream. I mean, I don't care if people are leaving the stream. I'm sorry. I'm grateful that you are like worrying about me taking a break, but the problem is I cannot take. This is the last day I have. This is the last day. Actually, the last day I have. I already postponed all my like schedules, so I cannot postpone it any further. I have other projects to work on, so I cannot end it. I cannot end it before completing the thing. So, right. I don't know. Why am I so stumped on this? 4a minus 5b has to be greater than 18. Let's just try it. Let's just try it. Let's just try everything. Wait, okay, what is happening? 10a plus b equals that. Okay, let's go back. Let's go back. You have that. I should just try every A. Let's just try every A. 24 minus 18 is 6. It's 42 minus 9. However, does not have a solution. If a of 7, then 20. $49, 40 minus 2b. Oh, right. I completely forgot about the D greater than... I'm just so... I'm so stupid. I'm so stupid. I'm gonna crash out. I'm so stupid. Okay, when did it happen? When did it... When was I... Right. Why am I so... Why can't I think about two things at once? I just have to think about two conditions. I can't think about two of them at once. Why? I can just leave out all of that. Okay. Since D... Three plus A. We have a LEQ 6. Bam. Right? That should be correct. So we only need to check for 5 and 6. 5 and 6. What kinds of projects do you have in school? I don't go to school. I graduated. Why is that a solve? Oh, I just have to move this. Move this to the thing. If BR let C equals 4, then 10A plus B equals 4A plus 4B plus 16 plus 4D. GEQ. Oh. GQ. 4A plus 4B plus 16 plus 4A plus B plus 4. So
2a minus 7b GQ 32. A contradiction. Therefore, the total number of cases is 7 plus 1 plus 1. Done. 10 o'clock. Number of integers n equals a to the b minus ab, a to the b minus 1 minus b. With a larger than 1 and b being positive integers such that n divided by a is this, is 1 greater than a multiple of ab. Kab plus 1. KAB plus 1 for some integer k. KAB plus 1 for some integer k. And has to be less than 10,000. KAB plus 1 plus b. Scratch me, I'll see you. Oh, not JK? Okay, whatever. A to the b minus 1 equals KAB plus 1 plus b. Let's try a few. Maybe mod both sides. B has to be a minus 1, like minus 1 mod a. So suppose B is MA minus 1. And M has to be right. Maybe it's better to do MA plus A minus 1. And then we have A to the B minus 2 is equal to K B no K A A times K times M plus 1 plus M plus 1 minus K. This has to be 0. M plus 1 equals K. That is unless A, no, has to be a multiple of A. It's not 0. It's not 0. That is unless B is less than or equal to 2. Mod A. A minus 1 mod A. Let B equals then, wait, forgot mod there. Then, why am I doing this? Why am I doing this? Well, then, okay. n over a 1 greater than a multiple of AB. Then, suppose b is greater than 2. Well, so what happens then? A, b minus 3. I don't know, just put something else here. Does this keep continuing? Maybe it does. Maybe it keeps continuing. I think so. Okay, the problem is I made this like that, but I guess the better way is to just have it be that, and have it be like this. Plus, wait. Plus b. M. Right. I think that's correct. Okay. B is larger than 2, then AKM plus M minus K. Right. And I think what I'm gonna do is have it be a series, maybe. So I'm just gonna add a subscript of 1 to everything there, maybe. Add a subscript of 1 to every k. And And instead of m, I'm going to write k subscript 2. Less than 10,000. I should limit A? Like... like less than 100? Right now, oh, because... less than this? So... K2 equivalent to K1 mod A. Let maybe that's what I'm supposed to do. Maybe. In each step, what do I get? K MA minus 1 plus M plus 1. No. Plus M. Less than 10,000. Less than 10,000. This is a So what am I doing? Wait, what am I doing? It's no, that's the wrong place. That's where. Maybe just write it like. Maybe. No, I don't know about that. Here. M. Oh! B is greater than or equal to A minus 1. Oh, right. I forgot. I forgot. Yeah, I always forget things. That's why I'm a fish. A to the A minus 1. So... Six times 6 times 6 times 6 times 6. That's like 1,000 times 6 is 9,000. 7. I guess that's gonna be larger. Okay. Right, it's just... I should just delete all my answers and start a new... Maybe... B minus... Wow. Wow, I need to eat dinner. Wow, I need to eat... Okay. Okay. It's okay. I can do it. I can finish it. I can finish it. I can finish it. I can finish this. A to the B minus 2 is K MA minus 1 plus M. That's correct. B, G, Q, A minus 1. A is less than 7. Oops, oops. What's 6 to the 4? Uh, $12.96 minus 5 is $12.91. Right. Wow. Wow. Wow, I need to drink water. Wow. Wow, wow, wow. 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 Wow, wow, my self-worth is crumbling. All of my mental is just crumbling here. I'm just in shambles. Wow, 1296 minus 5 is 1296. How stupid can I be? Well, I need to drink water. No, I'm just not fit for this challenge. Maybe I need to do. No, I can do this. I can do this. I can do this. I can do this. In this case, B has to be 4. In this case, N is equal to N is equal to 5 to the 4 minus 5 times 4 is equal to right, and N5 is that is a multiple of 5 times 4, 20. Break again. Suppose A equals 4. Seven if B is equal to 3, then N is equal to 4 times 3 minus 4, 4 to the 3 minus 4 times 3 is equal to 64 minus 12, which is 52. And frac N4 is 13, is a multiple of 12. AB equals 12. If B equals 7, then N equals 4 to the 7 minus 4 times 7, which is 2 to the 14 is this, minus 28 is anyway, that's larger, so actually right. suppose A equals 3, then B has to be less than 5, 8, 3 to the 8. How much would that be? I guess let's do B that because 3 to the 11 is much larger than 10,000. If B equals 2, then we have this. Then and I also forgot to say is 1 greater than multiple of AB equals 6. Okay. If B equals 5, then n equals 3 to the 5 minus 3 times 5, which is 243 minus 15 equals 228, and that's 76. Is it 1 greater than a multiple of 3 times 5? Yes. If B is equal to 8, then n equals 3 to the 8 minus 3 times 8 is equal to 3 to the 8 6561 minus 24 is 6537. And frac n divided by 3 is equal to is it 1 greater than a multiple of AB equals 24? Let's see. That's 192. Subtract that. 25. Oh. So it was 9. And if it's... Oh, right. Right. Right, so it doesn't divide. And suppose A equals 2. Then B has to be less than 15. Goodbye, Siam Masters. If b equals 1, then n equals oh. If b is 3, then n is 2 to the 3 minus 2 times 3, which is 2. Right. And frac n2, which is 1, is 1 greater than a multiple of AB. If B is 5, then N is 2 to the 5 minus 2 times 5 is 22, and frac N2 11 is 1 greater than a multiple of AB is 10. If B is 7, then N is 2 to the 7 minus 2 times 7 is equal to 128 minus 14, which is 114. And frac N2 is 57 is not 1 greater than a multiple of AB, which is 14. Actually, it is. It is greater. For 556, right? If B is 9, then N 2 to the 9 minus 2 times 9 is equal to 512 minus 18 is equal to 494, and frac N2 is equal to 247. Is it 1 greater than a multiple of AB is 18? No. No. Not 1 greater. Actually? Yeah. No. It's 18 times what? 18 times 15 is... No. No. If P, then N is equal to 2 to the 11 minus 2 times 11 is equal to 2048 minus 22, 2026. So that's where 2026 comes from, and frac N2 is equal to 1013 is 1 greater than a multiple of AB, which is 22. Not. I think not. Let's try. Actually, it is. Okay. If B is equal to 13, then N is equal to 2 to the 13 minus 2 times 13 is equal to 8192 minus 26 is equal to 66 and frac n2, which is 4083. Is it 1 greater than a multiple of AB, which is 26? 4082 divided by 13. 182. 52. 4. The total number of pairs, number of n values of n is one, 2, 3, 4, 5, 6, 7, 8, 9. Wait. I need to check. I need to check what I did wrong. If A is 6. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Solve. Hour 11. Number of integers n larger than 1991 that can be at the top of a number pyramid with a base of 12 blocks which contain a 0 or 1. In a number pyramid, the number in a block that's not on the bottom row is the sum of the 2 blocks directly underneath. So 12 blocks. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, question is, it's a sum of base of 20. So the base can only contain a 0 or a 1. How many integers can be on top that are larger than 1991? Let's see. Let's name these A1 through A12. This has... Actually, it's symmetric, so... Wait. A1 is only counted here once. It's also only counted here once. In this row, A1 is counted once. In this row, A1 is counted once. It goes on forever. A1 is counted once, so is A12. How many times is A2 counted? A2 is counted twice in the second row. And then... okay. So it goes like 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, and then 11 plus 1. Wait. 12, 11, 12. 1, 2, 3, 4. 2, 3, 4. actually, it's 11. It's counted 11 times. 11 times A2 and A11. A2 and A11. It's almost a Pascal's triangle. It's almost a Pascal's triangle, but at the end it becomes weird. At the end it becomes weird. What happens for the third one? What happens here? This goes here, here, and then out like this. And then out like this. Yeah. But then, when we are closing things like that, two C1, 3C1. 1C1, 1, 2, 12, 3, 9. Minus 9. 9C1. So it's gonna be 9C1, 9C2, 9C3. And then it's weird. It's really weird here. Nine C3 plus 2 9C2 plus 9C1. No, I did that wrong. It's 9. It starts from 0. Okay. No, I shouldn't even do that. 9C2 plus 9C1. Right. Right. A3 plus A10. Do it again. Eight C0 to 8C0123. And that's gonna be 8C3 8C3 8C0 plus goes here. Bum bum. 1, 2, 3. 3 8C1 plus 3 8C2 plus 8C3. A4 plus A9.
Uh, I. Um, 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 um. Eleven up to observe how many times one, two, 13 minus I. The value of each block gets added to 2 adjacent blocks on the next row. So the value of blocks in so the I blocks in row 13 minus I count the value of value of AI count binom n, or what is it? NCI 12 minus I as number the each the J block will count times the value of AI. From row to row 12 on each row the value the blocks on either side value of blocks on either side only get added to one block on the next row. This is a very bad explanation, but I don't know how to explain it better. It's a very hard explanation. Only get added to one block on the next row. So in row 12, the sum of all the block will have counted
compounded binom sum. Let's do a sum. I equals, I guess j equals 1 to I. Binomial I from 0 to 2. J minus 1 I. Minus 1. I think that it's a bad explanation, but that's it. That's the explanation. So this is 11. This is 1 plus 18 plus 36, which is 55. This is 1 plus 3 times 8 is 24, plus 3 times 28, plus 56 is gonna be 140, 165, 165, and then we need to calculate this. One plus 28 plus 6 times 21 plus 4 times 35 plus another 35. So that's 5 times 35. That's 126, 29, 155, 330. Finally, A6 plus A7 gets added 8C0 plus 5 8C1 plus 10 8C2 plus 10 8C3 plus 5 8C4 plus 8C5. I could be wrong. I need to check. So 11, 10, 9, 8, 6. Oh. Wait, I was wrong. I was wrong. Wait, I'm wrong. Okay. Wait. Wait, it's completely wrong. Okay, it's completely wrong. It's completely wrong. It's let's just draw all of them. Let's just draw all of them. I don't know. Let's just draw all of them because I am too... Bam, bam, bam. Bam, bam. 5, that's a 7. We have the 8. We have the 8 right there. We have the 9 right there. We have the 10 right there. I want to explain, but I don't have enough capacity in my brain left to explain. 5, 6, 7, 8, 9, 10, 11, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this gets added like that. Right. Right. Am I wrong though? Am I wrong? Maybe I am correct. Maybe I am correct. Wait. Okay, maybe I am correct. I just have to do this. 1, 1, 1 to 1, 2, 3, 4, 5. Okay. Okay. The problem is I wrote 8 instead of 6, so that's a mistake. 6. Put 6 is there. And I think then... Right. Huh. What's the problem again? Number of integers larger than 1991 that can be at the top of a number pyramid with a base of 12 blocks which contain a 0 or 1. In a number pyramid, the number in a block that's not on the bottom row is the sum of the 2 blocks directly underneath. Actually, so yeah. Actually, wow. I'm right, but I did a completely wrong approach. I did a completely wrong approach, I think. Because it's just 9, 10, 11. C3. This... Okay, this is really embarrassing. Right, this is really embarrassing. Didn't have to do that. each. Wow. I didn't have to go through all of this. I didn't have to go through all of this. I didn't have to go through all of this. But what's the better way to explain it? Just remove all of that. Reset my brain. Reset my brain. Reset my brain. Number of integers. And that I can think about that later. So, think of the intersection for the I block in the base. Picture a Pascal. I shouldn't say Pascal's triangle. Triangle starting from that block and continuing upward. Let's just use PowerPoint again. Wait, I can just use this. Bam. A of I. And save that as a picture. Save that. I don't want to. I can just delete all of these. Let's grab include graphics and put that here. And yeah, this block maybe. Reverse number pyramid, starting from that block and continuing upward. Row R and column of the I don't know, let's say J of the J block in row R, then since if the block of the original number pyramid were to be position of the marked in relation to block new pyramid, it would be in the where would it actually be? If I is 1, then it's, if I is 12, then it's at 1. Right? Position with the ith block, it would be the ith block, 13 minus ith block in row 12. Therefore, in the original pyramid, AI is counted by gnome 13 minus I, no, 12, 13 minus I times in the top block. Right? Oh, it's 11. No. No. Okay. Yeah, that's what it is. So at the number at the top of the pyramid is n equals sum I from 1 to 12 AI binomial 11 12 minus I AI. Boom. Now I need to find all the integers n such that okay. 1, 11, 55. $165. Did I calculate that correctly? Yes. 11, 10, 9, 8, 4, 3, 2, 1, 3, 330 times 7 times 5. 66 times 7, 42, 42. 4, 6, 2. If that's... I pray that is correct. I pray that is correct. So... it is... 6 plus a 7 plus 330 a 5 plus a 8 plus 165 a 4 plus a 9 plus 55 a 3 plus a 10 plus 11 a 2 plus a 11 and 1 a plus a 12. Let's do an align. Let's do an align there. What? Oh. Right. Right. Since 2 times so let's that times 2. 2, 22, 110 to what 330 660 and then 924 924 we need to add these up. $1,584. Oh, 19. What is it? 14. Let BI equals that for 1 LAQI LAQ 6 for n to be greater than 2. B5 and B6 have to be 2. Let's see. One 6, 1 7 something, 1 8 something. Actually, let's add it. 1 7 4 9. 1 8 5 9, and that's impossible. Okay. It's impossible to obtain n greater than if or we have b1 plus 11b2 plus 55b3 has to be greater than 462 plus 33 plus 165. B1. How much is that? We have 1991. That. Right. Right. It's 9 plus 3. What? Wait. Let's close. Did I miss something? This is not something. The sum of a Pascal row is just a power of 2? I do know that, but I didn't know how to implement in this problem. Right, but wait. How do I have wait? Oh. Not B 0. If then B1 and B2 can be any
number from 0 to 2, and none of the resulting ends are identical. So there are 9 cases. This results in 9 cases. If B is 1, then B two has to be 2. Greater than 0. So this results in 2 cases. 구미호님 감사합니다. 화이팅. 아 감사합니다. 열심히 풀어보겠습니다. In total, there are 11 cases of n. Values of n. That's 11. Now we're up to 12. Now we're going to 12. Number of solutions to the equation 3ab equals a squared plus b squared plus 620 if a, b, 6202. 3ab equals a squared plus b squared plus 620. Can we do like a squared minus 2ab plus b squared and make that work? Maybe this. A, B, 6202. We can also have 8 squared. Let's see, what can I do here? I don't know. Maybe a squared minus 3ab plus b squared is minus 620. Let's just remove everything else. A squared minus 3ab plus b squared equals minus 620. Then what? Not sure. Minus AB equals minus 620. Well, at least we know that AB is larger than or equal to 620 because of this. I have no idea. A, B. What is 620 doing? Let's try and see what 620 is about. It's 2 times 5 times 62, which is also 2 times 31. 6202, is that number important? Not sure. 6202. 2 times 3101. It's 2026 backwards.
The pyramid questions would have been on 7 o'clock if this was okay. Right. No. Not right. I don't know. Let's say... Okay, I need to look at the hints. They said they left a hint below the post. Hints for 12. If A and B is a solution, can you find another solution such that either A or B is equal to? So you're saying, let's say we have a solution. Can we just change one of them to get another solution? Can I change one of them? One of them to get the same. Change only one of them? Right. In that case, I can think of this as a quadratic equation, right? Like this. So this gives us another solution. This gives us another solution to B, which is 5a squared minus 2480. If B is a solution, then this must be an integer, so it should work. It should work. Both of them have to be integers. A squared equals 2480. A squared equals... No, not equals. It's 5 times a squared minus... is a square number. 5 times a squared minus 4 equals 20. 9 equals 45. 6 equals 30. Is square. So is 5 times b squared minus 496. So this has to be divisible by 5. Mod 5, that's 1. If a squared is 1 mod 5, what can it be? It can be 5a plus 1, 5n plus 1, not 2, not 3, not 4. I mean, yes, 4, not 5. So A and B have to be like these. And then what happens? It has to be a square. This has to be a square. Square. Let's just plug things in and see how it changes. That is a 5 times 5n squared plus 2n minus 495 minus 99. And this has to be a square. Is that possible? I don't know. Let's try plus 4 case 2. Then that becomes minus, plus 16. 5 times 9, 5 times 6. Yep. Are these possible? Is possible for these to be squares? I don't know yet. So what else can I get from this? Well. If I find a solution, is 496 squared? No. Is 496 a square number? It's 4 times 1, 2, 4? Which is 4 times 31. Maybe I just have to find a solution. Maybe. Let's just plug in numbers like AB6202, 5n plus 1 less than 6202, or 4. How can this be a square number? Does it? Well. Let's just plug in numbers and see if it actually becomes a square number. No. Can I just guess? Can I get? Is it possible to guess a solution? A squared and B squared and AB have to be around the same size. Kinda. If they're different, then it becomes weird. Because B squared, if B squared is larger than B is larger than 3A, then it's just impossible. So they have to be like at least close. And if they're around the same, then like A squared or B squared, one of them, if one AB is close to one A squared or one B squared, then it's like AB is kind of close to 620. AB is kind of close to 620. Does that even make sense? I think it makes sense. What is the square root of 620? How big is that? I think it's around, what, 25? Let's pick a number, let's pick A and B around 25 and see if it works. Okay? How about, like, what happens if I do, like, 24 and 26? What happens here? I don't think it's gonna work. 24 times 24 is 16. 16, 4, 5, 7, 6. 26 squared is 36, 12, 12, 24, 4, 6, 7, 6. 24 times 26 is 624. 3 times that is 1872. 576 plus 676 is 1252. Wait, that's a solution. Wait, that's a solution. Wait. I found one solution. A has to be smaller. A has to be 24. B has to be 26. Let's try a squared minus 496, maybe? Squared minus 496. So it was 576, right? 576 minus 496 is 80. And 676 minus 496 is 180. So we have B is equal to 3A plus or minus 2 root of 5 times 80, which is 5 times 16. And this one is 5 times 36. So it's like this. Or we can have A equals 3B, which is 678 plus and minus 5 times 6, which is 30. And this results in 46 or 26. This results in 39, 15, add them and we get 5, 4. So I don't know how to draw this. We have A equals 24, B equals 26, right? We have 24, 26, but then we have also found A equals 54, which is like here. And we have also found B equals 46, which is like here. And we can just go further, right? We can go further. Is the 5 also not under the root? Yeah. 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 So once I get that, so what do I do next? I got 54. I can also start from here and do 26 plus well, I can also go like 3 times 54 plus minus 5 to the a squared minus 496. Like that. I can do that again. And it should work again, right? So... Alright, am I just supposed to find all of them? I don't know. How will I be able to make the process simpler? Maybe? I already know that this part is going to be an integer. So what I need to know is just this. Right? Because it's going to be kind of... If it's 54, then it has to be... equal distance apart from this. I think. Yeah. Wait. 2. Yep. 81. 81. Which means... Okay, 24, 54, 26. And there's gonna be 81 there, and that's also gonna be a solution. I think. Did it work here to... 39. Is 39 right in between these two? Yes. Yeah. Can I get smaller? I don't think so. So, wait, 46? 54, 24, 36 is right between them. Okay. No, I didn't claim square root 5 times 16. So the thing is, what's in here is 5 times x squared minus 496. I mean a squared minus 496. And I calculated a squared minus 496 to be 80, which is 5 times 16. So if I put it in here, and that's going to be like this. So 5 times 16 inside a radical, that's going to be 5 times 4. So that is 20. Anyway, I think we can continue that and see when it becomes, when it goes above 6202. Okay. Can I go from here? 23 times 3 is 69. And we are... So let's say this is y. This is x. We want to jump from x to somewhere else. We want to know what this is. What do? We do this. And then we're going to do x plus z equals 2 times this, 3y. So it's basically 3y minus x. 3y minus x. That's what we're doing every time. That's what we're doing every time. Multiply this by 3 and subtract this. 1, 2, 1, 3, 8 minus 2, 4. 1, 1, 4. Jump from here again. Three times this is 3, 4, 2. Minus 4, 6 is 2, 9, 6. I believe. Yes. If I jump from here, we need we need 3 times this minus this. Right. 3 times this minus this, which is 243 minus 54 is going to give me 189. Actually, yeah. And then what? What is this? Bam. We have 3 times 189, which is 5, 4. 3 times 9 is 5, 6, 7. Minus 81 is going to be 486. 486. Let's just keep going. What is this? This is gonna be 296 times 3, which is 3 times 6 is 18, 3 times 9 is 27, 3 times 2 is 6, 8, 8, 8, and then 888 and minus 114 is 774. 774. And then what is this? Okay, what is this? It's weird. Am I actually just wrong? Because it feels like there are more than 12 solutions. Number of solutions to the equation, with a and b being positive integers. These are all solutions, no? Am I wrong? Am I only supposed to go one way? Is it impossible to go any other way? Actually, wait, maybe one of them is wrong. Ah, why am I so bad? 24, 26, 46, 54. So either it's 24, 46 or 26, 54. Okay. Let's see if they work. Let's see if 24 and 46 work. Let's see if 26 and 54 work. For this equation, 3ab equals a squared plus b squared plus 620. 3ab equals a squared plus b squared plus 620. Here's a, here's b. Here's A. Here's B. Let's do A, B. 24 times 46 is 6, 4, 4, 16, 2, 4, 8, 4, 10, 11. 1104. Let's do the same for 26 times 54. 26 times 54 is 8, 30, 10, 4, 1. 10, 4, 1. 1404. 1404. Okay. A squared, B squared. Let's do A squared. That's probably 576. Yes, it is. I know this is 6762. Yeah. So what we have left, B squared, 46 times 46 is 36, 6 times 4, 48, 16. 6, 1, 1, 2. 2, 1, 1, 6. 54 times 54, 16, 40, 25, 2916. 2916. A squared plus B squared. Uh, 2, 6, 9, 2. 3, 5, 9, 2. Plus 620. 3, 3, 1, 2. Plus 620. 4, 2, 1, 2. Right? Yeah. Yeah. Multiply this by 3. It is 3, 3, 1, 2. Multiply by 3. It is 4, 2, 1, 2. What? So these are all solutions, and it's not wrong. It's not wrong. It's not wrong. So, am I crazy? Am I just crazy? Did I mess up anything? I'm not sure. Okay, let's keep going. Let's keep going. 4, 8, 6 times 3 is this 24, 12, 8, 5, 4, 1 minus this number 189. I think it's this. I think I should use the Pell equations. I don't know what that is. Okay, let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Theoretically, there should be 2 more solutions. Only 2 more. Theoretically. 774 times 3 is 4 times 3 is 12. 3 times 7, 21. 21, 2, 2, 3, 2. Minus 296 is... It's gotta be minus 300 plus 4, which is this. And that's where we get 2026. Okay. So I'm not wrong. I'm not wrong. I'm not wrong. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? Maybe I am wrong. 1269 times 3 minus 486. Let's do this. 7, 10, 8, 3 minus 486. 7 minus 6 is 1, 2, 3, 3. So this is 3, 3, 2, 1. Correct? I think so. Some of the solutions are excluded since A is less than B, but like if you choose this one, you are choosing A to be 24, you're choosing B to be 26. If you're like choosing this one, you're choosing A to be 114 and you're choosing B to be 296. And I think then all of these should work. Okay, let's see if this works. 3 times 2026. 6078 minus 3 times minus this. Right? 5304. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 13. So I'm probably wrong somewhere. What method are you using to come up with new numbers? The way I did it was, I first got one solution, which is 24 and 26, and if I just try this, then once we get 1A, then B is equal to this, which means there are 2 values of B which are symmetric with respect to 3A over 2. So whenever I get a solution like A equals 24, B equals 26, I can choose another B, which is symmetric to 3A over 2. 3A over 2 is 36, and if you like reflect 26 to 36, that means like this is 10. So if you reflect it, you get 46. And so A equals 24 and B equals 46 is also a solution. And the thing is, this equation is symmetric, so I can do the same thing for A. So I can multiply B by 2/3 and then like reflect A with respect to this and get a new A. So that's what I did here, or at least what I thought I did. But seemingly I got 13 solutions. Let's see. Let's first write it down and see the solution. Let's write down what I have and then look at the solution.
square root of 9a squared minus 4a squared plus 620. Of I calculated here 3ab. Where did I calculate it? Should be somewhere here. Here. Okay. A and B is A1, comma B1. Then A1 3A1 minus B1 also be should greater among the two. Assuming B is greater value among the two. Since nine A1 squared minus 4A1 squared plus 620 must be an integer, and the two solutions to of B are symmetric to each symmetric to frac 3a over 2. Why am I using code? I have to write down the proof for each one. Triple in the given equation. So same works for A. If A1 E1 is a solution
then so is 3b1 minus a1b1. Which markup language are you using for this? This one I learned LaTeX to do this. I'm currently learning using LaTeX, and yeah, this is the first time I'm using LaTeX. Void Break, you're confused too. Okay. Unfortunate. LaTeX. What do we have? So Void Breaks donation. Thank you so much. I appreciate your dedication. Keep going. Thank you very much. I'm sorry, I couldn't look at the donation screen. This entire stream setup is just very scuffed because it is not really. I don't know how to set up a proper donation thing. So until like the end of the clock stream, I can't improve on that. Anyway, thank you very much for your donation. I will use it very wisely and creatively. Did I imagine myself solving these types of things? No! I originally wasn't even gonna do a stream until I decided to do it one day before like uploading the the announcement. So let me just put this up on my second monitor and just do so that's how it's gonna look like. 24, 46. 24, 46. And 46. 46 times 3 minus 24. 46. 114. Maybe I made calculation mistakes and that's why it was wrong. So I'll check what kind of mistakes I made after I write all of this down. 54, 26 times, 54 times 3 minus 26 is 54, 81. And then we have 114 times 3 minus, what is it? 46 is equal to 114 and 296. Then what do we have? We have 81. 81 times 3 minus 54 is 81 and 189. Uh, 189. 189 times 3 minus 81 is 189 and 486. 296. 296 times 3 minus 114 is, or is not, 296 and 774. Okay. Yozai, do you like fishes? Yeah. 486. 486 times 3. 486 times 3 minus 189 is 486 and 1269. So did I make a mistake here? I don't think this is a mistake. 50. Wait, that's the mistake. Okay. Okay, that's the mistake. Okay, aha. Everything after that was a mistake. Okay. Now I realize the mistake. Right. There's no way it's that. Or, okay, so I need to remove everything after this. So probably this one is wrong. But I believe now it's going to be correct if I do everything again. So, 54 times 3. I didn't multiply it by 3 maybe. 162. 162 minus 26 is gonna be 136, right? 136. So I hope that's true. 136 times 3 is 18, 9, 3, 8, 1, 804. Alright, minus 54 is 354. 354 goes there. 354 times 3 minus 136. 12, 15, 9, 2, 6, 0, 1 minus 136. And that gives 926. Right, 926. 926 times 3. 6 times 3 is 18. 3 times 2 is 6. 3 times 9 is 27. 2778 minus 354 is gonna be bam 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 2424, and this is gonna go outside of 6202. So that's this. That's it. That's it. That's it. That's it. That's it. Okay. 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 Bam. I have 136. 136 times 3 minus 54. 136 and then 354. 354. 354 times 3 minus 136 is 354, comma 926. Here we have 774. 774 times 3 minus 296 equals 774 and 2026. And 926. 926 times 3 minus 354 equals 926. And 2424. 2026. 2026 times 3 minus 774 equals 2026 and 5304. Beyond this, B becomes greater than 6202. So I technically haven't proven the number of solutions is 12. And I think that's enough for me. That's enough for me. Let's see. You say the B quadratic equation for A is the fact that AB is a solution. Substitute into the quadratic formula in the solution where is larger or smaller solution than A is B. B3A minus B. Yeah. Smaller solution out of a larger one. Smallest. Try to limit C. If we say that D equals CX, what do we know about X? What is that? Try to substitute CX for D. Well, they have to be closed. We know that. I didn't write it here, but I did know that. What values can this have? Say about C squared. Why can all solutions be built out of the smallest ones? Right. So I don't know how to solve those questions. I don't know how to solve these these proofs. Maybe this is when I can look at the solution in the 12 o'clock. Oh, maybe I'll do the bonus problem before that. Bonus problem. What is the size of the regular dodecagon if the area of the gray triangle is equal to 1? So if this is 1, this is 150 degrees dodecagon. Yeah. Yeah. So these have to be 15 degrees. So that means whatever this is, let's say this is X. This is gonna be tangent 15 degrees times X. And we know how to calculate tangent 15 degrees because tangent 30 degrees is gonna be 1 minus tangent 15 degrees squared over 2t. And we can solve this equation because tangent 30 degrees is 1 over root 3. We have 1 minus t squared equals 2 root 3t. T squared plus 2 root 3t minus 1 equals 0. Tangent becomes minus 3 plus square root of 3 plus 1. Is that... It has to be correct. It has to be correct. 2 minus root 3. So x times 2 minus root 3x is 1. So that's x, right? X is equal to this. And this is 2x. And we can divide this up into hexagon and 6 small triangles. The 6 small triangles obviously have an area of 6, combined area 6. And here, this is going to be 2x. And that is going to be 2 root 3x. Again, doable by 60 degree, 30 degree stuff, I think. And then the area of the hexagon is, if we divide it up like this, this is 4 root 3x squared, this part. And this part is going to be... That is x. That is root 3x. So this part is going to be root 3x squared. This part is also going to be root 3x squared. So in total, that's 6 root 3x squared, which is 6 root 3 times 1 over 2 minus root 3. So this is equal to... This is just 2 plus root 3. 2 plus root 3, which gives us 12 root 3 plus 18. And if we add all of that up, we get this. Maybe it could be wrong because my brain is fried right now, but I think it's 12 root 3 plus 24. Anyway, let's look at the solutions. I see that it is indeed 24 plus 12 root 3. They calculated tangent 15 degrees in a geometric way, but I think other than that, it's pretty similar. Haha. Okay. Okay. Right. Right. I believe that. I believe that. Okay. Okay. I will have to look through it again. But anyway, amazing job. Thank you for your submission. That is time for Cyan Froggy's clock. That is 11 hours 24 minutes. Cleared. Cleared, cleared, cleared. Now, we have 2 math clocks left, and we only have... What? 30 minutes until the stream ends, because YouTube can only handle 12 hours, right? Right? So... You might think this is impossible. You have 2 clocks left, and they are the hardest clocks. We have math clock, I suppose, here, with algebra that I don't know at all. And then we have this one from Pinkish Nova, which has a combinatorial game theory clock, which also I have no idea at all. Now, You might think this is the end for me. You might think? Now, it's over. You might think it's over for me. Because there's no way I know this. That this is literally graduate math stuff, right? Now, here's where... This is where you are wrong. This is where you are wrong. Because you know what I did yesterday and the day before yesterday? You know what I did for the only 3 days I have between the clock making project, between this math clock solving madness? In those 2 days, in my valuable weekend, I used the entire 2 days to research these 2 clocks. I used the entire 2 days to learn about algebraic number theory and algebraic what is even called algebraic topology, and then combinatorial graph theory. So here are my results. And obviously you cannot study 6 years of math in 2 days. It's literally impossible for anyone. So what I actually did was just a lot of searching. No AI because I don't use LLMs. No large language models. I can't see my pencil marks, so yeah, I hope you can see it now. But yeah. I hope you can see this. Here is the first one from LMath, math clock. Math clock, I suppose. Now, what is in 1 o'clock? Delta 2025 chain Delta 2026. And then it says 4 C Delta a chain complex. Now, what is this? A C? This is called a graded abelian group. And what's a graded abelian group? It's a sequence of abelian groups. What is an abelian group? Abelian group is set with an operation that satisfies associativity, like and then what is it called? Associative, commutative, associative, and stuff, whatever. I just looked through the textbooks and just saw one line that says any boundary is a cycle. And what that means is, where is it? What's a cycle? So, a cycle is an n-chain C with dc equals 0. What's a d? D is a boundary operator, and it sends sin n of x to Sn minus 1 of x. What is sin n of x? What is sin n of x? Great question! Sin n of x is a set of all sigmas, set of all singular n simplexes sigma in x. What is a singular n simplex? It's a function from delta to the n to x. What is delta to the n? Great question! Delta to the n is the standard n simplex, which is the convex hull of standard basis. Wow! So what is a binary boundary parameter? It does this. Whatever, it does that. And great, so chain complex is like the group of AN, graded abelian group, and then homomorphisms with d squared equals 0. And I don't care what all of those words mean. All I know is that any boundary is a cycle, and these are 2 boundaries, so this boundary is a cycle, and you put a cycle in a boundary that's at 0. That's just a 0. 0 factorial is 1. 0 factorial, 1. What's 2 o'clock? 2 o'clock is a field extension, L over K, where L is a K vector space. Then this signifies a degree of extension. This is actually I studied this while I was making the PowerPoint flag video. So QI means any
rational number and any I. I don't mean any I. The rational number plus the imaginary number I. And the basis for qi over q is 1 and I. So the degree of this is 2. Now, 3 o'clock. Delta 1 sigma if delta 0 sigma is 3. Now, this one is the one where I and I think modular discriminant here in the comments were both unsure about. And the original poster did leave a reply, but I still don't know what it means because all I know is that there is a line in the textbook says if where is it? If sigma forms a closed loop, then d1 sigma is d0 sigma. That is in the page 2 of what was it? Page 2 of something linear algebra. What was it? Miller lectures on algebraic topology, whatever. It was in that book. And I think what it means, whatever this is, I think what they meant was this is just equal to this, so this also has to be 3. But I don't think this makes sense as a mathematical statement, this being 3, whatever that is. But anyway. Also, what's a singular one simplex? Continuous blah, 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 blah. This one, honestly, don't know. This one, honestly, don't know. I don't know what D2026 is. Maybe it's a graph. Wait, maybe? Group names. It's a dihedral group of 2026. Okay. Dihedral group 2026. It's dihedral group 2026. Maybe. Divide that by what? R? I don't know. Maybe somebody will explain later. This one? I don't know at all. I don't know what this means at all. 5 o'clock. P. What is this? So this one was also pretty weird, but I've seen the textbook that they gave out in the comments, and all I needed to know is that this is called a skyscraper sheaf at P for S, and you write it like this: I and subscript P, then star, then S, which is a set, then U. So here we have I, then subscript P, which is 5, and then star, then S, which is a set, then U. And what is this? It doesn't matter anyway. It doesn't matter at all. If P is contained in U, then the result is just S. Now P is 5. This U is a ball that is centered at 5, which contains 5. So if P is contained in U, then the result of whole of this is just S. That's what it says in the textbook. So this whole thing is just S. S has 0, 1, 2, 3, 4. 4 elements, and this absolute value, absolute value of S, number of elements. So that's 5. What and does accident split into and divide by 11? I don't know. I don't know what this means at all. I thought it was like, what, maybe it has to be 77 after this, split into, like, divided by 11, and it has to be 77, but what makes 77? I don't know. I don't know at all how this makes 7. This is some military men whose steps vary. Plate in ebony and ebony? Ebony and ivory, how many are there? This is about chess. In chess, there are ebony, white and black and white pawns. Military men, pawns have varying steps. It's like when they start, they can go 2 cells or 1 cell. Chess pawns, 8. There are 8 pawns. Military men, yep, it's pawns. Now here, we have half of something, and now this one, I've looked through the group names website, and it says this could be C3 like product S3 or C3 what is it even called? Semi-direct product of C3 and S3, or a semi-direct product of C3 like whatever. It's one of these. The thing is, they all have like order of 18, right? This whatever this is, it's kind of ambiguous, I think, but I think it has an order of 18. So this thing is 18. Half of that is 9. Half of that is 9. This one, the original poster mentioned that it's a mistake, so they just removed it, said to change it to something simple like 5 plus 5. So that's 10. Here we have
dicyclic group of 3, and the size of that, the degree of that order of dicyclic group of n is 4n. So it's 3 times 4, 12, 1 to 12. This is 12, minus 1, 11. Finally, we have homology group for n spheres. And you don't need to know what a homology group is. All you need to know is that if if there's Sn inside HQ, these are the conditions. If Q is equal to n and they are both larger than 0, or if Q is equal to 0 and n is larger than 0, then we get this. If Q and n both equal 0, we get this. But as you can see, if Q is 1 and n is 2, then that doesn't satisfy both conditions. So it goes to otherwise. So we just have 0. So this is 2 to the 0, which is 1 times 3 times 4, which is 12. So that's a math clock complete. That's Elmath's math clock complete. I will not receive any questions because I don't know. Now to Pinkish Nova's game theory math clock, combinatorial game theory clock. Now, what is wait, combinatorial game theory clock. Yeah, this is it. Okay, what is this? Here, here. Now, okay. The fancy symbol for 6 o'clock is the symmetric group on n elements. The order of a symmetric group is then n factorial. Okay, 2 factorial is 2, 2 plus 1 is 3, 3 factorial is 6. That's what I thought, of course. Nice. So what are these? What are these? This is, I think, a game called Domineering. And in a Domineering, 2 players place dominoes on a grid. And the first person is called the left player. I mean, not the first person. One person is called the left player, and the other person is called the right player. The left player can only place vertical dominoes that look like this. The right person can only place horizontal dominoes that look like this. So, what this is asking is, what is the state of this game? Who wins here? How winning are they in this position? So, like, these are all cells. Like, if the left person, the one who places vertical cells, goes first, then they can maybe place a vertical cell, like, here. Vertical domino, I mean. Vertical domino here. And then the next person, the right person with the horizontal, could, like, maybe place a horizontal domino here. And then you keep going on until a person cannot place any more dominoes. And if you cannot place anything, you lose. Yep. So how this works is this is a neutral position. This isolated part is a neutral position. You don't know what it means. You don't have to know what it means. They cancel out somehow. This one here, this one is a horizontal 2x1 domino. Only the right person, only the one who can play horizontal dominoes can place a domino here. So this one is like good for right. You can place one move here. Right can place one move here. And if right is good by one move, you give the state a value of -1. That's kind of how it goes. So the whole thing kind of becomes -1. Negative of that is 1. So that's 1 o'clock. Now for 2 o'clock, this one is kind of weird because the closest thing I found to this notation is called star heated by B. But then I couldn't find out how this would ever resolve to 2. Because this is just, I don't know what this means. I don't know. That is heating? Because in all the Wikipedia pages, if you search for heating, heating, cooling and heating combinatorial game theory, and like I was looking at this and look at how t is on top of the integral, and here there's s and t bottom and top of integral, and like in our thing we only have one in the bottom of the integral, and so like I don't know how it works. I don't know how it's different. So yeah. Star heated by 2 left goes to 2. So is it just the same as this? So is it just this 2? Okay. So I learned that so we're essentially trying to do not 2. We don't know if it's 2 yet. We're trying to do this. And the thing is this is this. I think this is like, if this is a number then it's different, but otherwise you do b plus and then the L of that, or and then the right part is like this. And star left, this is just 0. Star right, this is 0, 0. We're also asking the left part of all of that, so it's just this, isn't it? It's gonna be b plus like something like this. So in essence, we're asking like, aren't we like asking this maybe? Which I was like, isn't this just 0? This is just 0, isn't it? So don't we just get b equals b? I thought we were supposed to get b equals 2. Because in A's case, A calculated to 1, right? B is this, but B doesn't calculate to anything. Yeah. That's what I got yesterday. You have to figure out by other numbers? Okay. Now, C is the birthday of C over D. Birthday of C over D is... Birthday of game G is the least n such that G is born on day n. And born is you first start from 0, and then you go like, do set of all like, I don't know, set of everything that you can make from... You can make from null and 0. So you get like null, null. I guess I should just empty them, but whatever. On day 1, you get all the things you can make with null and 0, and day 2, you can make all the things. You make all the things with these. A subset of those, and whatever. We know that n is born by day n. And 2 to the negative n is born by n plus 1. So now we do need to calculate d first, but if we already know that d is 4, if c is the birthday of c over 4, then the only way this is possible is if c is 3, because whatever, the you know, all the 1/4, 3/4, all these are born by day 3, and then after that, like also like 5/4 and 7/4 and stuff, they are born by day 3, and then on day n, technically everything up to 4n minus 1 over 4 are born on day n, I think. So if C is not 3, then it just doesn't make sense. Whatever, that's why it's 3. That is why it's 3. And then D, I don't know what this is either, because in the two textbooks I looked into, they didn't use these notations. Snort and Call. Snort is a game where you have to color blue or red, but you cannot color adjacent to another color. The game called Call is when you have to color blue or red. Like one person colors blue, one person colors red, but you cannot color adjacent to the same color. And anyway, these should be like blue and red cells. These are just taken from On Numbers and Games. I do not know what that is. On Numbers and Games. Okay, On Numbers and Games. Because when I searched for Snort online, it looked very different from that. It didn't have... No. Where is it? Like, it looks like this. It has empty and then blue and red. But then on our thing, we have circle and square. So I was thinking maybe circle is supposed to be one that's colored blue, white is supposed to be